Hello everyone and welcome back to my YouTube channel. Welcome to the yet another project where we are building an end-to-end AI application. So this is an on-demand video because in the last project that we have seen, which was completely built on the Azure ecosystem, so I received a couple of requests to build another AI application using an AWS ecosystem. So in this particular project, we are going to leverage all the Amazon services in order to build this end-to-end application. So this is an end-to-end project, end-to-end in the sense we are not only going to focus on developing the application, AI application, but also we are going to deploy the application, and also we are going to cover the front-end part as well. So everything, it's a full-fledged project, and at the end, once the deployment is done, we are going to automate the deployment with the help of CI/CD, that is continuous integration and continuous delivery pipeline as well. So please watch this particular video till the end. I may chunk this particular video into a parts, and yeah, I will upload the end-to-end video later on as well. But yeah, let's get started and see how it goes. So before jumping onto the application, let me quickly show you what exactly this application is going to look like. Okay, so this is the application that we are going to build as part of this particular video. And if you see, its name is AeroCare Maintenance. So from the name and thumbnail, you might have already judged the application, what exactly it is. So it's the application that we are building for the aviation industry in order to analyze their maintenance, in order to recommend some maintenance actions, and in order to prevent the accidents, and in order to prevent the disasters that are happening, right? So there are a lot many things that we are going to cover as part of this project. So before actually showing the demo, let's understand what exactly this project is all about. So let's understand the problem statement first. So the engineer inspects thousands of maintenance logs daily. So in the aerocare industry that we have, they are facing a problem where they are managing these thousands of logs manually. And whenever every flight lands, they capture a lot of sensory information, and based on that sensor information, they need to analyze the data and come up with a maintenance records, like, or come up with the maintenance steps that they need to follow. Obviously, we already know that every time the flight lands, what happens, the ground staff goes ahead and does the visual inspection to check whether everything is all right and not all right or not, and based on that they take a decision whether the flight is ready to take off again or not. So that is a manual evaluation that they do. Along with that, the sensory information that the pilot also captures some of the information, they fill the sheets every time whenever the flight lands, and that information they need to analyze manually, and accordingly they need to plan their maintenance. This AI application is actually helping in this particular regards only. So the manual analysis is slow. Also, there are high chances that the patterns and the hidden information that is available under this particular sensory records and other information that we are capturing, right? There are high chances that the people may, or the ground staff may, miss some of the information, which may leads to a high operational cost later on, because if you miss pre-maintenance, right, then it is going to lead to a major accident, it may lead to a disaster, or even it may lead to a high operational cost later on. So the project goal is to build an AI power assistant that analyzes the aircraft data, and I'll show you that data, predicts the failure. So based on the information that we are passing to the AI model, it will predict the failure points, and it will deliver intelligent maintenance recommendation. Now, why intelligent maintenance recommendation? Because whatever standard records maintained by the Aviation Federation, right, we are going to pass that standard metadata to the AI model, though it may be related to the standard process that we need to follow while performing the maintenance study, or while observing or doing the visual inspection of the aircraft, or while analyzing the sensor information, right? What are the minimum and maximum limits of each of the sensor that is available on the aircraft, right? So that manual we are going to provide to the AI assistant, and based on that, it is going to not only going to predict the failure points, but it will also generate the recommendation, and at the end it will give what are the maintenance steps that we need to follow, and it will generate a job card as well, which we can pass it on to the ground staff, where they can go ahead and perform that particular maintenance. Now, so what we are building as part of our AI powered solution is, we are going to upload and data that we are going to collect whenever the flight lands, every time the flight lands. That data, then we are going to analyze it and predict the risk, and also generate the recommendation. So if you see the steps here, first one, we are uploading the data. So we have a React front end. So the front end we have built it using React, which then call the backend, which is built on the FastAPI. Then for giving the AI capability, right, to use a large language model, we have Amazon Bedrock as a services, which is again a highly used service from the Azure in order to perform AI analysis, which will then predict and generate the recommendations, and those recommendations then we are showcasing it on the interactive dashboard. So this is not the normal chatbot that we are building, but it's an actual industry project where it is beyond chatbot, right? Like we are actually showcasing some interactive dashboard which is helping the users to analyze the data quickly. And we have already seen the technology stacks like React we are using for front end. FastAPI is a high performance backend API that we are using. Amazon Bedrock to consume the large language model. Docker in order to containerize the application. Amazon Elastic Container Registry in order to host our Docker image, and then EKS, the Kubernetes service from Amazon, in order to deploy the application. So these are the cloud native deployment that we are going to use. And at the end, once the deployment is done, we are going to automate the deployment through an automated CI/CD pipeline using GitHub Action, which is again a very famous tool used into the industries. And the key benefits are obvious, like faster analysis, smarter decisions, and a scalable and automated system that we are planning to build. So enough of theoretical part. Now let's go ahead and actually see the application demonstration. So I'm taking you to the application. There are a couple of details that we have added, and we'll see that once we start building the application. So if you see a landed flight is ready for assessment. So whenever the flight lands, we are going to pass some information. So here the user can upload the information. So I'm choosing a file and I'm uploading this aircraft maintenance data. What exactly this data is? So if you see, this is the information that we are going to pass. So if you see, we have a aircraft information captured from the sensors. So for AIR 001 flight, we have close to 100 records. So if you see, so these are the 100 records that are available. So if you see the flight cycle, so it is 100 cycle. So 100 times the flight landed and took off. And then we have the flight hours, how many times the flight flew, then flight cycles, and then the last maintenance rate that we have, and then some of the sensory information like ambient temperature. Then we are capturing the humidity, the outside air temperature, engine temperature, the exhaust gas temperature, then we have oil temperature, oil pressure, engine vibration, and many more, then hydraulic pressures and many more information that we are capturing. And then in the past, what and all sensor information, what and all actions that we have taken, right, the maintenance that we have performed. So we have this particular information. Now whenever new flight lands, we will be adding that information in this particular sheet, and we will upload this sheet. So now let's say for AIR1, right, we are doing the analysis. So it is the 101 record. So let's go ahead and do the analysis for this particular record. Okay, so let's go back to the application, and let's click on generate engineering analysis. Now this engineering analysis, right, what it does, it actually analyze the past information that is available in this record, right? So we have 100 flight information. So last 99 flight records, right? Those records, it will compare it with the 100th record. 100th one is our latest record. Let's say today the flight has landed and we have captured the 100th row. Now on that 100th row, it will go and do some historical analysis. So which is a complete analytics that we have built in Python, which will go ahead and generate these recommendations like, okay, what exactly is the engine temperature, what's the exhaust gas temperature, oil pressure, everything it will capture. And based on these temperatures, right, it will generate this report that, okay, ambient temperature as compared to the historical records, as compared to the last 99 records, what exactly is this current record? So it is decreasing. So if you see, ambient temperature is decreasing, humidity is increasing, 55% the humidity has increased as compared to the average of last record. So this engineering analytics, right, it is basically identifying the mean, median, and other parameters from the past records, and it will calculate the average as well. And then we are comparing the 100th record with the average of last 99 records. Next time, whenever 101 record is going to come, it will compare it with the last 100 record. So it's like that. And this is, so as till this point, there is no AI. It is just the analytics that we have built. And now the moment we are clicking on generate AI recommendations, it will go ahead and generate the recommendation. But before that, if you see, you can upload the maintenance PDF. We have already added a default PDF, but let's go ahead and choose the file. So this is the Aerotech ATX maintenance manual that I'm uploading. And what exactly this manual is, let me show you. Okay, so this is the Aerotech Aviation System. So this is a standard manual document maintained by the Aviation Federation. And what actually it is doing is, it is having all information related to the turbine, all engine components, what are the minimum ranges, maximum ranges that are allowed, what are the maintenance activities that we should be taking care of, the roles and responsibility of each and every engineers and everything, safety protocols, everything is mentioned. And if you scroll down, you will see, okay, if you see the normal operating parameters for engine temperature, this is the normal operating range. For exhaust gas, this is the normal range. So the AI model that we have, it is going to consume this information as well as the analytics information that is coming from the analytics module. It will compare it and accordingly generate the recommendation. And those recommendations, right, it will again generate the recommendations to perform the maintenance as well. Because in this, right, we have again added a, if there is any hydraulic leak, then what are the symptoms that it shows, what are the maintenance activity that we need to perform. All that information is available in this standard guide. So it's close to a 25-page PDF that we are going to pass to the AI model. So we have selected this particular PDF, and let's go ahead and click on generate AI recommendation. Now this will analyze the complete information that is captured for flight AIR 001 with the latest record that is available when the flight landed, and it will compare it with these standard ranges that are available, and it will generate the recommendation. Now this, it has called the AI model which is serving on the AWS Amazon Bedrock. From there it will call the AI model and it will pass this information. We have written a good prompt in order to generate the recommendation, and accordingly it will generate the final recommendation. Okay, so if you can see now, it has generated the AI recommendations, and what it is saying is for flight AIR 001, monitor medium risk and safe for flight, meaning the flight can safely take off, but we need to perform some monitoring action. And what exactly it is, so the current aircraft is in monitor state due to slightly elevated engine vibration levels. All other parameters are within normal operating ranges. Increased monitoring and inspection of bearing assembly is recommended before the next flight. So it has mentioned that, okay, we need to perform a maintenance activity on bearing. So if you see now, the recommendation is aircraft may fly with increased monitoring, and the engine vibrations are slightly above the normal range, and vibrations are generated because of the wear or because of the bearing wear. So you can see this is the engine vibration, which is 6.08, which is above the threshold. So this is the threshold, right? Warning 3.1. If the threshold is above 3.1, then it generates the warning, and if it is greater than 4.7, then it's critical. And this is the root cause analysis, that bearing where engine vibration tends to increase, and engine temperature and EGT, right, just gas temperature, are above normal but below critical threshold, so that is fine. And the maintenance section, inspect the bearing assembly and rotating components. And then it has given this information, and if you see, it is again giving the reference that, okay, go ahead and visit chapter 6 section 6.5 from the document that we have provided. So if you go to the section 6, right, if I'm searching section 6, okay, so I came to the section 6.5 bearing inspection procedure, and we have given the procedure, standard procedure is available here. So based on that procedure, it is saying that, okay, we need to go ahead and analyze these particular rotating components, and then the inspection checklist, visual inspection should be done, and oil debris analysis should be done. And AI is 80% confident about this particular failure analysis and the inspection it has given, and it has generated the work order that, okay, bearing inspection and monitoring AIR 001, perform visual inspection, analyze oil debris, and use these particular meters, bore scope, in order to analyze these reports, and use oil debris kit analysis kit for the oil inspection. So it has generated this recommendation. So how beautiful it is, right? So we are leveraging an AI capability in order to come up with a fast recommendations, and it is generating the job card at the end, which we can send it to the ground staff. Now let's play with it. Let's add one more record. Let's say the new flight has landed. So after this particular 100th row, right, let me copy and add one more row here. And let me change the flight to 101 now. And the flight hours is, let's say, now 390. And cycle is 101. Let's change some of the dates. Let it be on this date only. And let me add some high values. The ambient temperature, let's say it is 30 degrees Celsius. Then the humidity is, let's say, 150. Now the outside air temperature is, let's say, 36. I'm just changing, adding the high value. So in order to check whether it is generating the recommendations or not. Engine temperature is, let's say, 1500, which is pretty high. Gas exhaust temperature is 1000. I'm just purposefully adding the larger values. Oil temperature is 250. Oil pressure is, let's say, 100. All these engine vibration is, let's say, 15. I'm just adding some high ranges so that we can check what are the recommendations that our AI engine will generate. Hydraulic pressure, let's say it is 5000. And yeah, that's it. Risk score, let's take it to 98, and let's see. Now I'm saving this file, and let's go ahead and perform the analysis again. So let's refresh the application, choose the file. I'm adding this data, click on generate analysis. Now if you see, the risk score is high, the vibrations are pretty high, Then if you see, now we can see the red everywhere because it has increased the we have increased all the values, and if you see ambient temperature, everything is increasing. And now let's go ahead and click on the generate AI recommendation. We have uploaded the file once, so no need to upload it again. In case your manual has updated, if you have come up with a new manual with new values range and advanced techniques, then you can upload it. Now click on generate analysis. Now it will compare the latest 101 record that we have updated, right? That with these particular values and the historical values along with the manual that we have uploaded, maintenance guide, it will generate the recommendation. Now let's see, it should generate some severe impact and it should not allow us to fly as well. So let's see what recommendations it generates. Okay, so the analysis report is here. Now, if you see, ground the aircraft, meaning it is saying you are under critical risk, ground the aircraft. You are not allowed to fly. So the aircraft has exceeded critical thresholds for engine temperature, exhaust gas, oil temperature, engine vibration. Immediate maintenance is required to address these issues before aircraft can be considered safe for flight. And this is the final recommendation to ground the aircraft. And these are the values where the aircraft has violated these normal ranges. If you see, everything is greater than the minimum threshold or the average threshold that is available, and root cause analysis is multiple critical threshold violation detected. And then if you see the maintenance action, inspect cooling air duct, inspect turbine fuel scheduling, then it is saying inspect oil cooler, inspect bearing assembly, and these are the inspection checklists that it is giving. And again, the 80% is in the AI confidence score, and this is the work order that it has generated. So how beautifully it has recommended to ground the aircraft and not to fly with this particular aircraft again. First complete the maintenance activity and then you will be allowed to fly. Yeah, so this is how this aerocare maintenance industry is helping the aviation industry in order to avoid the mishaps. And also it is generating the quick recommendations so that you can go ahead and quickly perform the maintenance, and you can reduce the maintenance activity, maintenance time, as well as you can reduce the cost that can be incurred due to the negligence of minor failures that are happening, which may lead to an major cost later on. And also it reduces your downtime because of the maintenance activity later on if major breakdown happens. So that's the application that we are going to build as part of this particular project. So if you are interested, right, in the next video we will cover the coding sections. Also we will go ahead and see the architecture of this particular project, what and all components that we are using from the Amazon, from the other components that we are built around it, right? So everything we will be seeing it, and then we will also go ahead and deploy the application on the AWS ecosystem, and we will build an end-to-end CI/CD pipeline as well. So in the last video, we have already seen the application demonstration, and we have seen how this particular application works, what are the inputs and what output data it generates. Now in this video, let's focus on writing the code. So we will be coding this particular application. As this application is divided into two microservices. First one is the backend microservice and second one is the front-end microservice. And as this is a real industry project, right? So we are going to follow these industry standards. So in industry, generally what happens, right? The backend developers are different and the front-end developer team is different. So these two teams collaborate together in order to work on these projects. So backend team develop their backend application and the front-end team develop their front-end application, and then they deploy their individual services. We call it as a microservice. Now, let me quickly show you how exactly it's going to look like. Okay, so this is our logical architecture. I will explain this architecture when we start coding the application. I don't want to confuse you. And this is the physical architecture. So whenever we are going to deploy the application, at that time I will explain this. But for you to understand now, so if you see, these are the two microservices that we will be building. The first one is the front-end React and then the back-end FastAPI. Now we will spend more time on the back-end because that's the heart of our engine. Front-end is just the looks and feels, right? So we will not focus much on that, but this back-end we will see it thoroughly. Now, without wasting time, let's straight jump onto the coding and other these components, right? What are these CI/CD, these gateway, application load balancer, everything I'll going to cover as and when we are going to work on those particular services. I will explain it along the way. Now let's open a VS Code. Okay, so I have opened Visual Studio Code, which is my favorite code editor. You can use your favorite code editor, PyCharm, or if you want to use any other, you can feel free to go ahead and use that. So please create a folder AI aircraft maintenance platform, and under which we are going to create two folder mainly for two microservices. First one is the backend, where we will keep our backend code, and second one is for the front end, where we will keep our front end code. right? So these are the two microservices. So under backend, let's create one more folder called data where we will keep our data. And also let's create another folder source where we will keep our source code. Under data, let me go ahead and add the data source. So we will be using two files. So let me go ahead and paste it. So we already know that. So the first one is the standard manual that is maintained by the Aviation Federation, where we have defined all our standards that are required while doing the maintenance, or what are the sensory standards. Everything is decided, right? Everything is added in this particular document. And second one is our Excel, where we have actually kept recorded our sensory information. So those two data sources that we have added. So let me quickly show you. This is our data that we have added, where we have the aircraft related information and the sensor data. So this is our Excel file. And second one is this aircraft engine maintenance. So this one is the inspection manual, where all our standards are defined, like the minimum maximum values of the sensors, and also what are the maintenance that we need to perform on the breakdown of any component. So all those information is written in this particular manual. Okay, so once these two are done, now you can go ahead and start writing the code. So first step is, let's go ahead and create the virtual environment. So I can go to the backend. Now everything we will be writing into the backend. So under backend, let's create a virtual environment, and I'll be using a UV as a Python package manager. So let's use UV when. If you have not installed the UV, just go ahead and install the VB by using command pip install UV. This will install the UV for you. So I have already installed the UV. UV is a Python package manager which is very fast. So if you see now, let's create a virtual environment with command UV when. If you are aware about this process, you can feel free to ignore it. Now this is the command to activate the virtual environment. So let's go ahead and use this. Now if you see, we are using Python 3.12. Now you also make sure that you are on Python 3.12 to make sure this project works smoothly. And let me add the project YAML file. So what happens with the help of project YAML file, you will be able to quickly set up this particular project as well. So I'm pasting this particular file. So this is the project.toml file that I have added. So you can get this file from the GitHub repository. I will drop that link in the comment section in the description below. You can take it from there. And if you already have this particular file, then it is pretty simple for you to set up this particular project. So for now, what I can do is, let me clear the screen. And in order to use this particular file, you can just do UV and sync. This will go ahead and sync your project. So if you see, the moment I done UV sync, it is reading this particular file, and then it is setting up this project. So it has installed these dependencies that are required. So it is doing that installation. If the VNV is not created, it will create the virtual environment. And that's how, if you see, all the packages are under the source folder. So it is defining those. So it is pretty simple. You no need to do the manual setup. So if the project.toml file is available, so feel free to leverage this particular file in order to set up this project in your local. Now this is only the backend setup that currently we are doing. So let's wait for the installation. Okay, meanwhile the packages are getting installed. Let's go ahead and start writing our code. So under source folder, let me go ahead and create one folder called, let's say, aircraft maintenance. So under which we will write all our code. So this is again an industry standard. You create multiple routes, you create multiple these subfolders where you keep your module code. So we call it as a modules. So under this, first of all, let's go ahead and create our first file. So I'm going to add our first file. Okay, so this first file is the engineering analytics. So as you can see, our installation is done and we have the virtual environment. So if I go ahead and do Python -- version, it should write 3.12. So let's see. Okay, you can see we are on 3.12. Let's clear the screen and let me go ahead and show you this particular code. So first code that we are building is the engineering analytics. So let me take you to the diagram now. Okay, so in this diagram, if you see, the first part that we are building is the engineering analytics. And the task of this particular module is to read the sensory data, fetch the last record, calculate the historical metrics, and generate the aircraft analytics. So this aircraft analytics contains the historical average, median, standard deviation average, and the change percentage. So at the end, it's going to generate the data in this particular format. Historical analysis like the column, ambient temperature, what is the latest value, the historical values and all. So this is how it is going to generate the record. Okay, so let's go ahead and build this particular engineering analytics first. Okay, now let's go ahead and debug this particular code together so that I will explain the code while debugging what actually each and every step is doing, right? Okay, so first of all, if you see, step one is the analytics module for aircraft maintenance intelligence platform, and this module loads an Excel maintenance dataset, selects an aircraft's latest flight record, analyzes this recent history, and returns a neutral statistical context as a JSON-ready Python dictionaries. So pretty simple. We have done some imports, and without confusing you, let me go ahead and take you to the main function. Now in the main function, if you see, I have given the dataset path as .backend. Under backend, there is data folder, and from data folder, we are reading this particular file, intelligent dataset.xlsx. Now in the engineering analytics, we don't need this particular maintenance PDF, manual PDF, because we are just going to generate the analytics. So based on this Excel sheet, right, we are going to check the last records of this particular flight. Let's say if you are taking an example of flight AIR001, we will take the last examples and we will find out the average, then the median and all those details, and accordingly we are passing those details to the AI model. And that's what we are going to build as part of this particular file. So let me add a breakpoint and we will go ahead and debug this particular code. So let me debug this Python file. Okay. So first of all, this is the dataset, and we have selected aircraft ID as AIR001, for which we are going to do the analysis. So let's go ahead and debug this code together. So first of all, let's go inside the aircraft engineering analytics. So here we are creating an object. So let's go. We have defined the dataset path. We have given the sheet name. So this is the sheet name which is available under this XLSX file. Let's go inside. So if you see, we have defined the Excel path, then we have defined the sheet name and data frame that we are going to define. Now this is where we have created the object. Now let's move ahead, and this is our main function. So first of all, let's go ahead and load the dataset. So under analytics, we have load dataset as a method that is written. So let's go inside the load dataset. So if you see, this is the load dataset that method we have written inside this particular class. Now I'm not calling it as function because the moment we switch under the class, the function becomes the method. So these are the general loops concepts. So if you're not aware, just in case if you're not aware. Okay, so the load dataset, what it does, it loads, cleans and validates the Excel dataset. And so if you see, first of all, it is checking whether the path exists. So let's go ahead and check. Okay, the path is exist. Move forward. Next one is the logger. Now we have added a logger because this logger, right, it is very much helpful whenever you are deploying the application. This logger helps you debug if there are any issues, and trust me guys, this is very important to add the logger. So whenever you are writing code, please go ahead and add the logger. And in the companies, right, it is again a standard coding practice to add the logger, because in your local, right, you can quickly fix your issues, but when the application is in the deployed environment, right, then it becomes very difficult to track where exactly the component is filling, which component is filling. So that's where the logger is pretty important. Now first thing is data equals to pd.readExcel, very simple command. So we are reading the data set. So if you see, now it is reading the data set. So let's go ahead and check whether the data set is loaded. So if you see, this is the data set, it has loaded. You can check it from there, or you can go to the debug console, and here the name of the variable is data. Let's go ahead and enter. So if you see, this is the data that we have read: aircraft ID, aircraft model, and the other parameters, other columns that we have added. So data set is loaded. Then the next part is we are calling a clean columns. Now under the this particular function, we are calling another method that is clean columns, which does a very simple task like normalize the source Excel headers into a Python friendly name. So if there are any special characters, the brackets, everything, it is removing it. So if you see, it is doing that removal operation. That's the simple thing that it is doing. So let's quickly do this, and then I will show you the columns that are converted. Okay, then we are normalizing it, very simple. And stripping, we are stripping it in order to make sure that we are basically stripping all the columns. Now this is a for loop, so let me come out of the for loop and post this. If you see, now let me go ahead and print the clean columns, so you will see the clean columns. Oh, sorry, let me again print the data so you will be able to see the data set. Okay, so we have cleaned the columns. Now, once the columns are clean, the next step is it is just checking validate whether the required columns are available. So if you go inside this, we have defined the required columns. So these are the two required columns, aircraft ID and flight ID. And there are many more, but yeah, we will quickly see what and all other details that are important. Then we are converting this particular into the numeric flight cycle because those are in the numbers, pretty simple. Then we are dropping the duplicates from these two columns, aircraft ID and the flight cycle. Then it is just converting it into the int, very simple. Then we are sorting this value. Now why sorting is required? Because once you sort the data, you will have the flight records in the order they flew. So what happens, right? You are taking last couple of records in order to perform the historical analysis, and it's required for that purpose. So here we are doing that activity, and then yeah, we have our data ready. So let's select next. Okay, now we already have the data set available with us. Now next step is to using this analytics object, we are going to generate the summary. So let's understand what exactly is there inside the generate summary. So now we are again into the generate summary method. And here if you see generating the deterministic engineering analytics for one aircraft, and this method does not call an LLM, it prepares trusted structure fact that then can be passed to the Bedrock model later. So for this, if you see, we have already selected the AIR001 as a aircraft ID. We are getting the latest record. Next is we are getting the previous record. So if you see, these are the previous records. Now, if you want to see the latest records, how we are getting it, it is pretty simple. So if I'm going into this, right, if you see from the history, we are just taking the last record. Pretty simple. And then, so here if you see, we are getting this particular history. Now we are getting the previous record. So under the previous record, so let me show you what exactly it is. So let me plot the history. Now in this history, you will get the records, last 100 records. So if you see, these are the last 100 records. In our Excel for AR001, we have 101 records. If you see, we have 101 record, out of which the previous records are 100. So those records we have selected. Now let's move ahead. So now we have latest and previous record. Let me show you the latest record as well. So latest record is pretty simple. Only the last row of AIR001, like aircraft ID AIR001. Then these are the information. And if you see, the flight hours is 101, flight cycle is 101. That's the cycle that we have selected. So if you go to the last record, flight cycle is 101. So this is the latest and previous record that we have extracted. Now next step is doing the historical analysis. Now let's go into the calculate historical analysis and we will check what exactly it is. So first thing is we have defined the format, and here we are identifying the sensory columns. What are the columns that are having the sensor information? So we have defined these columns which has the sensor information. If you see, we have the ambient temperature, these other details, ambient temperature, humidity, and the outside air temperature. Those are the sensory columns, so that we have defined. So these are the numerical columns, and let me come out of it as it's a for loop. Let's go inside it, and now we have the historical analysis. I think it came one step back. Okay, and in the historical analysis, what we are doing is, once we have defined the columns, so if you see, we are getting the latest record, average we are calculating, median, standard deviation, change, and change percentage we are calculating, and those values we are appending it into the list. So these are the simple values that we are calculating based on the data frame that we have defined. And this is for the last 10 records. If you see history window, we are picking the latest last 10 records, and we are doing this analysis only on those 10 records. Again, you can change this number just to reduce the complexity. I have kept it 10, but yeah, you can give these for last all the records as well. Now this is where it is generating the final summary. Now if you go back again, so in the engineering analysis, it will go ahead and fetch all these details, and then if you see series to JSON ready dict, here it will convert all these elements into the JSON object. So here it is just converting it into the JSON. It is pretty simple. Let's come out of it, and historical analysis we have defined, and now let me show you what exactly this historical analysis looks like. So if you see the summary here, okay, So let me show you. So if you see engineering analysis summary, so aircraft ID 001, this is the flight cycle, this is the current record in the JSON object, aircraft ID, aircraft model, and then if you go historic analysis, so if you see here we have defined the historic analysis like column humidity, latest value is this, historic value is this, and all those details it has extracted. And with this last command we are just printing it in the JSON object. So if you go to the terminal it might have printed. Okay, if you see this is the final object that it has given. So these are the value. Aircraft ID, this is the latest record. And then the historical window size is 10 and this is the historical analysis. For each column, ambient temperature, this is the latest value, historic value, all those information is there. So that's how we have created these particular engineering analytics for the sensory columns or sensory features. Now, as we have this information, now we are going to pass this data to the AI model along with this particular maintenance manual. And here now we are going to add another file or another module, that is the Bedrock maintenance analyzer. So let me add that file. Okay, so this is the Bedrock maintenance analysis, and let's go ahead and debug this particular file as well. Now what I have done is under the main function, so let me take you to the main function first. Under the main function, so if you see, I have added this engineering JSON, whatever we have obtained out of that particular last module in order to test the object. So this underscore underscore main equals to, sorry, underscore underscore name equals to main, meaning this file is this particular code, right, whatever is there after line number 255 will be executed only if you are running this as a main file. Main file in the sense, if I am doing Python bedrock maintenance analyzer.py, then it will execute this file. And in order to test these individual model, we write this particular code. So if I'm going down, let me add the breakpoint here and let's go ahead and debug this particular file as well. Okay, so first Bedrock client, we have defined the Bedrock client. Now this client we need to create it first. So if you see Bedrock runtime and region name East US that we have defined. So first of all, we need to go ahead and deploy this particular model, or we need to create the service in order to access this model, Amazon Nova Pro P1. Right. So for that you need an active AWS subscription. So if you don't have any Amazon subscription, I would request go ahead and create that. You can use the free service. Now free service, you can definitely create a free service which gives 200 worth dollar free credit, and those are more than enough for you to build this particular project. So I already have the account, and if you want to understand, right, how to create the free account and all, you can go ahead and check out my another video. I will drop that link in the comment section. So let me go ahead and open the login to my account. So AWS login, let's go management console. So here you can click on sign in and you can get started. So you can get started with the free account. So I'm signing in. I already have the account. So I'm signing with a root user. Now what is root user and IAM user? I'll talk about that once we go into the service. So I'm selecting my account. Let's go. Let's complete this. Okay, so let me skip this authentication part for now. So this will take me to the AWS management console. Okay, we have logged into the AWS. Okay, so now the service that we are going to use from this particular AWS is the Amazon Bedrock. Now, Amazon Bedrock is a fully managed service provided by the AWS, which gives us the feasibility to access the large language model. So let's go ahead and search the Bedrock here, and this is the service Amazon Bedrock, under which you will see now multiple large language models that are available that you can go ahead and use. So on the left side, you can see you have multiple tabs available, and we will see whatever tabs that are required as part of this. If you see, click on model catalog, you will get the multiple models that are available that we can go ahead and use it. Now we are going to use the model from, if you see, we have the models from Claude. The latest model of Claude is also available. Now, if you select Amazon, we will be using native Amazon models. So if you see, these are the models that are available. And we are going to use Nova Lite model, which is, I think this model that we are going to use, which is Nova Lite V1 1.0. So if you see, this is the model Nova Pro. Okay, not Lite. We are going to use Pro model. You can use this model as well. That's fine. I have just picked one model. I think it's this model. Sorry. Yeah, this is the model that we'll be using, Amazon Nova Pro. So you can use any model, that's fine. Now, we cannot directly use this model. In order to use this model, first of all, you will have to go ahead and create a user, and you need to grant access to that user so that that user can go ahead and access the model. It's like you can consider it from the security stand perspective, right? You need to create a gateway in order to connect or come into your AWS service from your local terminal, and that is what we are going to create for now. So first thing is you will need a service called IAM. So go to the IAM, Identity and Access Management, and under this, first of all, you need to create a user. So currently there is no user. You ignore these roles and everything that I have given. It is as part of my other things that I am working on. So first thing is that you need to go ahead and click on the IAM user, and let's go ahead and create a user. Click on create user. Let's give the name as iTech user. I'll give iTech user as a name. iTech is our YouTube channel. So if you have not subscribed to the channel, please go ahead and do so. And let's click on next, and click on attach policies. This way we are attaching policies so that that particular user can go ahead and access the Amazon Bedrock. So here you can search Bedrock and we will give full access to the Bedrock. So if you see Amazon Bedrock full access, so that it can read the models that are available. Let's click on this. Let's next create user. Once the user is created, we will need some details from this user. So let's click on this user and click on create access key. So this way it is going to create the access keys with which we will be able to connect to this particular services that are available on Amazon. Now let's go ahead and click on next. We have selected command line interface because through command line we are going to connect. Sorry, let's select the checkbox, and let's skip this particular part. Now access key and secret. I will be deleting these secrets before uploading this video, so make sure you are not sharing your secrets with anyone. So let's go ahead and open your terminal. First of all, you would need a, let me stop this particular debugging that we are doing. First of all, we need to do the setup. So let's clear the screen. Now, first of all, you would need a AWS client. So you can go to the and search AWS CLI. So this, you need to install this AWS CLI in order to make sure your AWS command will work on your local terminal. So you can, sorry, AWS CLI installing or updating the CLI, you can go to that, and you install the CLI based on the system that you are using. You can go ahead and install it either Linux, Mac OS or Windows. It is pretty simple. Just like you install the game, you need to go ahead and either you can download a MSI file and then click next, and it will be pretty simple, or you can use this PowerShell command to activate it. Now this is pretty simple, so I'm skipping this step. Once you do that, then you will be able to execute these commands in your AWS related command in your terminal. So first of all, let's check whether AWS, you can execute this command by typing AWS. Yes, so we can use that. So the first command in order to configure the local terminal with the AWS service is AWS configure. So hit this command and it will ask you to add the access ID. So I'm adding my access ID that we have created. Oops. Let's go ahead and copy the access ID. And then you would need this key as well. Let's add it. Let's select the default region, default output format. Okay. And I'm going to save these secrets so that if required later on, I can use it. Okay, so this part is done. You can either download a CSV as well. And now, as we have already configured the application, now the next step is you can go ahead and debug this. So for that, again, let me click on debug mode and let's continue the debug. Okay, so we are till this point. So let's skip this part now. And if you see, we are creating the client and then we are passing this model. We are setting the temperature as 0.2, max tokens is 2000. So to generate the output as close to 2000 tokens. And this analyzer is ready. Now let's go ahead and analyze the result. So here we are passing the engineering JSON. So whatever this JSON that we have defined, we are passing that JSON and then it is going to analyze the result. So if you want to see that, let's go inside it. And under this analyze method, we are passing the engineering analytics and it is generating a structure AI maintenance. So first thing is we are building the prompt. So let's go ahead and see what exactly is building the prompt. So let's go ahead and we are just dumping the JSON. So, and then next part is, let's go next and done. And if you see, this is what it is returning in the building prompt. This JSON we have converted into the dumps so that it has converted into the proper format. And then this is the prompt. You are a senior aircraft engineering maintenance engineer. Your task is to take the engineering analytics, then and attach the internal aircraft maintenance manual. And these are the important rules that we have added. You go ahead and read these rules, and then this is the required analysis that we need, whether we need the health status, failure severity, threshold violation, whether we can fly or not, root cause, confidence, and generate the work order. And we are passing that engineering analytics here, and this is the output format that this particular model is going to generate, like the aircraft, then its model, health, risk level, then overall summary, threshold violations, root causes, maintenance actions, inspection checklist, and work order. Whatever we have seen in the demo application demonstration, right, all those details are exactly same. So the same thing, we are requesting the model to generate the output. Now the model is going to generate the output in this particular JSON object itself. Now if you go next, let's go next, then we are stripping it, and this is where our prompt is built. Then we are loading the manual, so let's go inside it. And if you see now, manual PDF, whether the manual PDF is available, if the path is available or not, that we are checking, and then we are reading the manual. So we have loaded the manual, and this manual is loaded into the bytes format. So if you want to see the manual bytes, currently it is in the bytes format. So under the debug console, if you write manual bytes, so you can see all these byte values and the path that we have used, right? So if you see, from this particular path we are reading the aerotech maintenance manual. So the manual is read, and then we are calling a conversation API from the model that we have defined, the Amazon Pro model. And if you see, role we have defined as user, context, then we have passed the prompt, and then we have also passed the document. This is the name of the document, and the sources manual bytes, whatever bytes that we have read, that we have passed. And in the prompt we already have the engineering analytics response, so that is what we are generating. So let's go ahead and complete this part. So we already have the conversation ready, and then if you see, we are calling directly the client, the Bedrock client, and we are using the converse function in order to converse with that particular model. And these are the temperatures that we are setting. Pretty simple. Let's select this and let's see what response it is generating. Now it is actually calling that particular API. It is calling the Amazon model from the AWS, and it is generating the response. So it will take some time, so let's wait for that. Okay, so you can see the response is already generated. Let's see what's there inside the response text. So if you go ahead and check the response text, so this is what it has generated as a response. Aircraft is this is the model. And if you see health status, monitor, risk level medium, safe for the flight, true, all that information it has extracted. Fly with monitoring, everything that it is now extracting and generating the response for. So it means our call to the LLM was successful, and it has retrieved all the response and it has generated the response in the required format. And then we are parsing it into the JSON format. So if you go one step ahead and let's see what is there in the result. So if I print the result now, under result you will see the result in the JSON object. So if you see, aircraft, this is the aircraft ID, aircraft model, then health status, monitor, risk level, medium, safe for flight, yes, all that information is there. And if you want to print it, now go to the terminal, and the moment I print it, it will print all the information in the JSON object. So if you see, this is the information that it has generated, meaning it has the call to the LLM was successful and it has retrieved the information in the desired format. So if you go back to our diagram, now the first part, right, engineering analytics, this we have built where it has retrieved the historical analysis. Second part we have built is AI maintenance recommendation, which has used the Amazon Bedrock. This is the model that we have used, Amazon Nova Pro, which took input as the threshold values from the maintenance guide and this engineering analytics. And based on that, it has generated the recommendation whether it is safe to fly or not and what maintenance is required, and this is the output that it has generated, right? Like the success, the call success, and then the report, like this is the aircraft, and this kind of report it has generated, health status and all those values it has generated, and a work order, inspection checklist, maintenance action, root cause analysis, everything it has retrieved, and that's the same output that we have obtained. That's the backend application. So we have built the heart of our application, and now the next part is just to convert this particular project or wrap this particular project into a fast API format so that we can build a API out of it. So the next part is pretty simple. We are just going to build the APIs. Okay, so to build the API, it is pretty simple. I will perform a couple of changes and then I will show you. Okay, so I have done a couple of changes. So under source folder, what I have done is I have added the constructor in it so that we can import this particular aircraft, this source folder as a package, and it's required to wrap an API around it. And under aircraft maintenance, again, I have added this constructor so that we can call these particular uh, classes that we have written inside these particular modules. We can easily import those. So basically with the instructor, we have converted these particular Python files as a modules. Now that's the simple Python trick in order to basically convert your projects into the Python packages or convert your code into the packages. Now that we have done, and then I have added the app.py, which is a FastAPI application that we are going to build around this. So let's understand what this code is. So it is a simple FastAPI backend for aircraft maintenance platform. And these are the three APIs that we have added. First one is the health check, aircraft analytics, and the maintenance prediction. Same, whatever we have seen as part of those two, engineering analytics and the Bedrock maintenance, those two APIs we are going to build and we are going to test those APIs. We have done the imports, and now if you see from the source aircraft dot maintenance, so with the help of those constructor that we have added underscore init file, because of which we are able to import these particular classes by referring these as a Python packages. Source aircraft maintenance, Bedrock maintenance analyzer, we are importing the aircraft maintenance analyzer, and from the aircraft maintenance we are importing the aircraft engineering analytics, those two classes. So if you see, we use this particular class to generate the engineering analytics, and we use this particular class to feed the information to the generative AI, feed this information to the large language model. And then with simple fast API we are creating the fast API. And at the end, we have added the main function just to start the application. So we are using uvcon.run, and we are running the application on 8000 port. So let's quickly run the application. Let me clear the terminal. To run the application, it's very simple, Python app.py. Sorry, I'm not in the backend. Python app.py, and it will load the application on the 8000 port. So let me go to the port 8000. Localhost 8000, and you can see status okay, aircraft maintenance API is running. And in order to check the Swagger page, you might be knowing already, on fast API if you write docs, it will open the, okay, you can see this is the fast API, that application that we have created. Currently there are no operations that we have defined, so let's go ahead and define those applications. So let me add it quickly. Okay, so I have added the routes. So first one is just to check the status of the application. Then this is the health check application route that we have added. Next route is the aircraft analytics route, which takes the Excel, and based on that Excel, it generates the analytics JSON that we are feeding to the Amazon Bedrock model. Now it is pretty simple, same things that we have used. So if you see, from analytics we are calling the aircraft engineering analytics, and we have just added some other details so that to make it a API specific, and then it is returning the details into the dictionary format. Similarly, we have added this another route. So first of all, let's And similarly, we have added another route in order to do the maintenance prediction, which is again, if you see it is, and same thing, it is taking the payload from the first API, and that payload it is going ahead and passing it to the LLM. So if you see again, these are the other details that it is accessing. So now it requires the access key, secret key, and all other details that are required in order to access the model. And then if you see again aircraft maintenance analyzer, it is using this particular analyzer. Now these details are required. If you don't pass these details for now, still it will work because you have already signed into the AWS through your account, through your user account. So this will still work, but in the production environment, it's required. So we'll see that. Let's not hurry it. So we'll see that step by step. And it is pretty simple. So let's go ahead and refresh the application. And if you go ahead and refresh this, now you will see all the APIs that we have created. So first one is the root API. Let's exclude this. Let's try it out, the health check API. So it should say that, okay, the status is okay, meaning the application is up and running. Now, first, let's try the aircraft analytics. And in order to try that, sorry if I'm explaining this too fast. So just to save the time, I'm explaining this particular stuff very quickly. Now, again, the API handling and everything is pretty simple. So if you want to try it out, let's click on try it out. And here you can pass the file that we have. So let me open the file. So this is our aircraft maintenance file. So we have added it. Let's execute. Now, the moment we execute, so if you see, it is generating the response in the same object format. Aircraft ID, summary, and then the historic analysis. So it is just we have converted those Python functions into a API. So we have wrapped that particular code into the API format. So these are our two backend APIs, main backend APIs. Now this particular response you can copy, and then you can go and execute the maintenance prediction API. In the maintenance prediction API, if you click on try it out, you can just pass that same detail and you can click on execute. Now this will take some time because it is now hitting to our AWS console, and from there it is accessing the model. Accessing the model in the sense it is accessing the Amazon model, and then it will return the response. So this particular engine analytics, we have passed it to the large language model now, and this large language model will generate the response in structured format. So let's wait for that. Okay, so if you see, it has generated the response. So this is the response body. Aircraft is this. Overall summary, the aircraft AR1 has exceeded critical thresholds and all those temperature values, everything it is given. And this is the final response that it has generated, meaning this particular part is working. Now, both the APIs, front-end as well as back-end APIs are working as expected. Now, the next step is we need to deploy this particular backend application. Now, currently, if you see, this particular application is running on localhost 8000 port, and we need to deploy the application. Now we have two steps. Either we can complete the front end part as well, and then we can deploy both the application together, or we can work on the backend application deployment first, and then we can go ahead and build the front end as well. So to keep this code dynamic, right, I think we can go ahead and deploy this particular application, backend application first, and then we can work on the front end as well. So whoever is not interested in front end, they can skip the last part. So okay, let's do that way. So for now, we have the backend code ready. Everything is set up in the backend. Now the next step is, in order to deploy the application, we need a Docker. So Docker in order to containerize the application. So let me open the diagram. So let's go to the physical architecture. Now this part is ready. We have already built this FastAPI backend application. Now we need to containerize that particular application so that we can go ahead and deploy it. Okay, so let's go ahead and Dockerize the application. So in order to Dockerize the application, let's click on create new file and give the file name as Docker file. Okay. Now the Docker file building is pretty simple. So if you have watched my previous project videos, we have already covered how to create the Docker file. So first thing is we are going to load the base Python image. So as we are using Python 3.12, let's use the Python 3.12 slim image. Now what this Docker file is going to do, Docker file is a set of instructions that we are adding, from which it is creating the Docker image. Now first our target is to make sure the Docker file is running locally. If the Docker file is running locally, then only it will work on the deployed environment. Now, the importance of Docker file is that if you are not aware about it, it makes sure that it containerizes your application so that you can ship that particular application to any environment. If this Docker file works in your local, right, it will make sure to run on your deployed environment as well without any issues. In the software development, right, we always face the issue. If, let's say, if I'm a developer, I work on the code, it will work smoothly. But the moment I give this particular code to the tester, and tester is doing the setup, and most probably the application will fail under tester system, and it's because the system configuration is different. The one that tester is using is different, and the one that I'm using is different. And in order to avoid this issue, right, we are using a Docker. So with the help of Docker, if that Docker image is running in your local, you can give that Docker image to your tester, and it will make sure that once he pulls that particular image, that Docker image will work on his or her laptop or any system, whatever they are using, without any issue. So to fix that issue, we are using the Docker. And also it becomes very simple with the help of Docker file, because once you create the image, you can easily deploy the application. You can just pull the image from the deployed wherever you have pushed it, and you can easily go ahead and deploy the application. And we are going to see all the steps in detail. So first, for now, we are focusing on this part now, creating the Docker. Then we will see how we can push this particular Docker, this particular part, how we can push the Docker to the ECR as well. ECR is the Elastic Container Registry. We will see that what exactly it is. We'll talk about everything. So the next part is, first of all, as we are using UV, so we need to add the command to install the UV. So I have added the command to install the UV. If it is not, then we are setting the working directory. So under the environment, wherever it is creating the image, it will create a working directory /app, and it will push or put all our code inside the app directory. Then next part is of every application is to copy the requirements file and install it. And to install the requirements, we will be using pretty simple command, that is run uv pip install -r requirements.txt, and we are basically adding the command to avoid the system cache. And then we are copying the complete code. Now with this, it is copying the entire backend source code into the app. So whatever directory that it has created, whatever code is available under backend folder, dot if you see, meaning first dot is whatever code that is available in this first dot, it will be pushed to the second dot, that is the working environment, wherever it is that we have defined. And then we are defining the expose port where the application should be exposed. Again, it is optional. If you want, you can skip that. And last one is the command to run the application, ubicon app and the port. So this is our Docker file. Now let's go ahead and build the Docker image. Now these are the setup instructions that we have added into the Docker file. Now next step is we will go ahead and execute this file so that it will create the image into the local environment again. Now this will be creating the Docker image in our local itself. So for that, you need to install the Docker desktop in your machine. So if you don't have Docker desktop, just go ahead and search Docker desktop and install it. It is again pretty simple. You just need to hit, just like you install the games, you need to do that installation. So for now, I may have some old images. I will go ahead and delete those images. So let me go ahead and delete everything that I have so that it will not confuse you. And containers as well, let me go ahead and delete all the containers. So some containers were running, so it could not delete all the files. Okay, so if you see, I don't have any image and I don't have any containers available. Now let's go ahead and once the Docker is installed, you need to basically, the commands are pretty simple. Save this particular file, and the command to build the Docker image is pretty simple. Docker build -t, and let's give the name as this is the backend microservice. So let's give the name as maintenance backend, and dot, with dot meaning whatever is there, it will go ahead and create the Docker image for. So if you see now, it is creating the Docker image. So it is building it, then it will, okay, it is copying everything into the Docker file. It will take some time. So first of all, it is loading the Python 3.12 slim image. Once the image is loaded, then it will copy the requirements and install the dependencies. Okay, now if you see, it is running the pip install uv, and then it will go ahead and, yeah, it is currently installing the UV. Once UV is installed, it will copy everything from the requirements and install the dependencies as well. Okay, if you see, it has created the work directory. This particular command it has executed. Then it is transferring the context, whatever is there. So it is doing this particular copy activity. Oops, it has failed. Oh, sorry. I missed to add the requirements.txt. So let's go ahead and add it. As we have used the project toml file, so I missed to add it. So I have added the requirements. Requirements are pretty simple. So let's go ahead and execute the command again. Okay, so it has copied the requirements. It is doing the installation. So now if you see, it is doing the installation using UV pip install and the requirements.txt. Now once the requirements are installed, then it will copy the complete code. So if you see copy dot dot, it is going to copy everything, the source code copy. It will copy the source code into the working directory. And once that part is done, then it will go ahead and build the complete image. Okay, exporting the image, exporting layers. The last step is pending. Let's wait for that. Okay, so the image is created. Let's go ahead and check whether the image is created with the command docker images. Docker images. So if you see maintenance backend is the image that it has created and its size is 2.62 GB, and you can validate that by going into the Docker desktop and images. So this is the image. You can run the image directly from here, or you can use the command here to run the image docker run and the name of the image, name of the repository that we have created. So this will go ahead and run the Docker. Now, if you see, now it has started the application. Now we are not manually running the application. We are running the application through Docker. So if this particular endpoint works, it means our application will work on the deployed environment as well. Now again, let's go to this particular link. Let me close this, or before that, let me show you, or before that, let me close this first. Let me go ahead and take you to the local host first. And on localhost, if you see now the application is down, it's not working because I have terminated the code. And now let's go ahead and run the Docker run maintenance backend. Now it should run the application using Docker. So if I go ahead and reload it, okay, still the app is not running because we have made one mistake. We need to define the port while running the Docker. So the command is docker run -p. We need to define port is 8000 and redirection port is again 8000 and then the name of image. Now let's run it, and now it should run. Now let's go ahead and reload it. Okay, you can see status okay, servicing, so it's working. And if you go to the docs, okay, so it has opened docs. Let's go ahead and quickly check it out. Let me upload the data, execute it, and let's see. Okay, it is generating the analytics successfully. Let's copy this and let's test the second main API. Try it out. Let's pass it here and let's execute it. Maintenance failed because unable to invoke the Bedrock model. Okay, so it is not able to invoke the Bedrock model because as we have wrapped this particular, as we have Dockerized the container, now it is saying that in the Docker environment, this particular model is not defined. So it is not able to invoke that because the ITIC user that we have created, it is not, we have not added those configurations into the Docker environment, and this is where the problem occurs. Whenever you test your application in your local, it was working because you have manually configured your AWS credential. But in this particular one, it will not work because the moment you ship this particular Docker to the your testers, right, they will start getting this particular error. So to fix this, you need to define these parameters. So let's go ahead and add the .env file. So here you can create .env file, and under the .env file, we need to add these parameters that we have defined here. So these parameters we need to define. First one is the access key, and second one is the secret key. So let me add these two keys here, and then we can go ahead and execute it. Okay, I have added the secrets. Now what we need to do, we need to go ahead and again rebuild the image. So to build the image again, the command is pretty simple. Docker build -t maintenance backend dot. So this way now it will load the environment. So for now again, this is not a standard way. We are pushing the .env along with this particular code. But in the deployment, right, we will make sure we are not pushing the .env, and we will be adding these secrets into the GitHub secret whenever we will work on the CI/CD part. So let's wait for this particular image to build, and then we will go ahead and see that, and then we will go ahead and run the application again. Okay, so the image has been created. Let's go ahead and check again. Docker images, we have created the image with same name. Now let's go ahead and again run. So docker run -p and this command, so it will go ahead and run the docker. Okay, so let's go to the application. Let's refresh it again. So okay, I lost the JSON, so let's go ahead and try it out. Let's choose the file, execute it. This is working. Let's copy this, go down, and here let's pass it and execute it. Now it will go ahead and access the Amazon Pro model that we have defined on the AWS, and it will generate the response. So let's wait for it. Okay, you can see it has generated the response. So this is the final response body that we have obtained. Meaning now this particular code, whenever you are shipping this particular container to any environment, this code will work into that environment. You just need to make sure that you are sharing the environment secrets with secrets. You need to set these environment secrets into the deploy environment, and this particular backend application will work smoothly. Okay, so with this now we have basically Dockerized our one microservice, that is backend microservice. Now in the next part, what we will do is we will go ahead and deploy this particular backend service manually. So we will be following an imperative way of deploying the application. And once the backend microservice is deployed, we can go ahead and check the front end microservice. Okay, and that's what is actually done in the industry. So the backend team is responsible for backend application development and deployment, and the front end does their own way. So if, and that's where we used these two different microservices, right? So in the last project, I have used single microservice, and we have deployed the backend and front end together. But this time, in order to build the actual real industry project, now I am building backend as a separate microservice, front end as a separate microservice, and we will deploy these services on a AKS cluster. So if by chance, if any of these particular microservice goes down, only that microservice gets will be impacted, and not both. So, and not the complete application. So again, going back to our diagram, so now we have done this particular part. We have built this particular FastAPI microservice, and we have Dockerized the application as well. Now we have the container ready. The next part is to move this particular container to the ECR, that is the Elastic Container Registry, and we will follow a standard documentation in order to push that particular image. And once that image is pushed, then we will go ahead and create this particular AWS cloud. We will create this EKS, that is the Elastic Kubernetes Service Cluster, and we will deploy the application into that. Now, and also we will go ahead and build the front end as well. So maybe instead of deploying the backend separate, for now let's go ahead and build the front end application quickly, dockerize this particular application, and then we will work on the deployment together. So let's follow that way. Okay. Okay, so as our backend application is ready, now let's go ahead and build the front end. So we being the data scientist or AI engineer, we no need to focus much on the front end code, but still just to cover it quickly, we will not go much into the depth of front end code, but I'll just explain the high level components, and then we will go ahead and wrap the Docker around it, and then we will deploy it. So let's get quickly started. So let me go ahead and add the front end code first. Okay, so I have added the front end code. Let's go ahead and understand what exactly it is. Okay, so first of all, let's go ahead and check what exactly is there in the source folder. So first part is the API. So we have written all the backend APIs here. So if you see in the client.json, we are reading the white base URL. So this is the API, like we already have one microservice that is backend. So this is the backend where exactly our backend application is running on which particular link. So that's what we have given here. So default is the localhost 8000 port that we have given, and then this is the white package. And then this is the base URL link that we have defined. So which we will define it into the environment file. So if I open the environment file, if you see, we have defined the same link here. Once we deploy the application, at that time we will have to change this link to the actual backend application. And then under the client.js, if you see, we have defined multiple these application endpoints. So if you see in the backend, we have added the backend health check, then backend first one, that is the aircraft analytics, the engineering analytics. And if you see, we are uploading the file as well. It has the option to upload the file. And the next API is the aircraft maintenance prediction. So all those three APIs that we have added here. So this client.js is going to talk to the backend application, and it is going to send the request. So if you see the method and the uh, metadata that we are going to send to these APIs, and from there we will get the response. So under component, we have panel card. So again, it is just defining the panel body. Next important file is the main.jsx, which is the main application, file. So if you see, which defines what and all details the application is going to access. So if you see, from app we have imported app, and from the styles we have imported the CSS. So we have defined these two details, and this is the main application starting point. So let's go ahead and check the app. So under the app, we have defined all the logic that is required in order to build these, in order to call these API endpoints and everything that is written in this particular file. Again, as I mentioned, we are not going to go into the depth, but if you see some of these icons and everything that is mentioned here, the way the JSONic objects that we are showcasing it on the UI, all those details that are available in this particular file. So the next one is the style.css. Again, no need to mention no need to explain this file, because it's again just the styling effect that we have added, the color combinations, the font, everything is managed in this particular file. So if you can see, right, all these styling related stuff, right, like each word, what are these color combinations for each word that is available on the UI, everything is defined as part of this particular file. Then git ignore is simple file that we are adding the git ignore files that we need to ignore, like the node modules. Once we install the packages, then once we install the third-party packages, it will come under the node modules. Index.html, and then we have package.json. Package.json is in order to capture the requirements that we need to basically install. And then last one is the white config.js. It's just the configuration file which defines on which port the application is going to run. Okay, so this is all. Now, this is the front-end code, and I'm not going into the depth, but if you think that I should cover the front-end code as well, just let me know. But it is pretty simple, and we being the data scientist, we don't need too much focus on these front-end code, but we are going to cover the deployment of both the codes. So let's get started. Now, because in most of the organization, right, if the team is pretty small, then backend team is ideally responsible for the deployment as well, and they take care of deployment of front-end application as well, and they build CI/CD around both. So that's where, just for you to make sure you are aware about all the end-to-end the deployment process and the continuous integration and continuous delivery process, I'm going to cover it. So let's get started. So first of all, we need to create the Docker file. So under this, let's create a file, Docker file, and let's start writing the Docker file. So the first thing that we need to write, okay, before the Docker file, let's go ahead and run the application, whether this application is running or not. So I'm opening another terminal. We have this terminal. So let's go to the front-end code. And first of all, in order to install these packages, you need to go ahead and install the node. So you can go to the node, just search node install, and go ahead and install the node if you have not. So go and based on your system, right? Let's say if it is for Windows, go ahead and download the MSI file or binary file and go ahead and install it. Just like you install the game, you need to click next, and it will be installed. Pretty simple. Once the node is installed, you just close your terminal and open it again, or close the VS Code and open it again, and you should be able to see the node. So once you type node -- version, it should show the node version. So if you see, I'm on v24.18.0. So make sure you have the version available. Make sure you have the node installed. Now, once that part is there, now it's time to install the dependencies. To install the dependencies, we need to use the command npm install, which will read this particular package.json file, and it will start installing the dependencies. And if you see, it has created this particular file node modules, and under this node modules, if you see, it has installed the dependencies. So it was pretty quick. Now, as this part is done, okay, vulnerability is found, npm fund for details. Okay, let's see if it fails. We will go ahead and check it out. Now, Okay, this part is done. Now next part is to run the application. To run the application, you can use command npm run dev, and this will run the application on 3000 port that we have defined. So in the config file, if you see, we have defined the 3000 port. So let's go ahead and open the 3000 port. Localhost 3000. Okay, so if you see, we have loaded the application. So this is your user interface, and it is saying failed to connect to the backend. So backend is currently offline. So let's see what's the problem. So for that, you can go ahead and check the backend, whether the backend is running. So let's control C, and we need to make sure that the backend was running on the Docker file. So let's use the command python and app.py. This will make sure the backend will run on 8000 port. Okay, it is running on 8000 port. Now let's go ahead and refresh this. It should show that the backend is online. Okay, it is still offline. Let me check that. So let's check whether the backend is running. So localhost and go to the port 8000. Okay, so backend is running fine. Let's go to the talks and check. Let's try uploading the file. Okay, so the backend is working. So let's check what's the issue. It is returning 200, and the moment I'm hitting the backend, it is throwing 405 method not allowed. Okay. Okay, so I understood the issue. So I think the method is not allowed, meaning we might not have set the middleware under the backend app.py to accept the request coming from the front end. So you can go to the source and you can go to app.py under backend, and here you need to add that. So we need to add this app.add middleware. So what this middleware does it, so if you see, it is going to allow all the origins. So whatever request that is coming from one browser, it is going to allow that. Now this is basically from the safety perspective. So whenever you are not adding this, one service cannot call the another service. So your front end cannot call the backend if you are not adding this, and this is generally required in order to maintain the security of the application, so that your application cannot be directly called by any of the middlewares, and that's the reason we need to add it. So we have added it. Now let's go ahead and refresh the screen. So let's close this app.py and let's go to the application and refresh it. So it should, okay, you can see it is reading the backend now, so it is able to access the backend. And let's choose the file and let's see if it is actually going ahead and generating the engineering analytics. Okay, so it's working, so no need to call this particular part. So our backend to front end call is done. Now what we need to do is, or let's go ahead and generate the recommendation just to check whether everything is correct or not. So now our backend and front end, both the applications are running on local. So congrats, you have built the both backend and front end application on your local. Now the only part that is pending is the deployment. So we are going to see two parts of deployment. One is the imperative way of deploying the application, which is also called the manual way of deploying the application, where we will create the services manually, then we will basically run several commands to deploy the application. And second one is the automated way with the help of continuous integration and continuous delivery, where it also called as the deployment through YAML file. So we are going to add all the details into the YAML file, and that we are going to basically deploy the application with the help of those YAML files, and we are going to automate it using the GitHub action. Okay, so the AI part is also working. So the complete backend and front end, both the applications are completely working. Now, in order to Dockerize the front end, let's go ahead and create a Docker file. So we already created the Docker file. Let's start adding the code. Now, why Docker is required again? Because the front end application also, we need to containerize it and ship it to the deployment environment, so that this front end is a separate microservice which will run on one cluster basically, and the backend will run on another cluster or maybe on same clusters, and then they can communicate to each other. So if anything bad happens to the front end, only front end code will be impacted. If anything bad happens to the backend, only the backend code will be impacted. So it's managed in that particular way. That's where we follow a multi microstructure way, or we keep these services independent, so that it is very easy to fix if there are any issues. So in the Docker file, let's quickly start putting the details. So first thing we need is the lightweight node module. So with the help of this, we are going to use this particular node image, node 20 Alpine. We are going to use the node 20th version and Alpine image. Again, the way we required Python in the backend, right? Similarly, we need Node here in the front end. So if I open the backend file, so if you see, we have added Python 3.12 Slim. Similarly, we are adding for front end is the Node. Then next part is almost similar to the file that we have defined here. So let me split it. Okay, so let me show these two files side by side so that it will give better visibility for you. So the next command is simple. Again, work directory app. Then in the Python, we have added requirements.txt. So here we need to add package.json. So if you see, first we are creating the work directory, then we are copying package.json to the package and package log.json into this particular working directory. And next step, again, if you see, it is giving me the recommendation to install the dependencies. So run npm install, which will do that particular activity. Then we are copying the rest of the code the way we are doing here. So we have done copying the code, and the last command is to run the server. So to run the server, we can use the command npm run dev. So dev is basically used in order to run the application on local or in development environment, but when it comes to the production, we use the command npm build. So that's the command we ideally use. But yeah, let's get started with this. Let's save this file, and let's go ahead and build the Docker image. Now let me close this part as well, and again let me interrupt this. And again, building the Docker is pretty simple. I can keep this running. Under the front end, again we can use the same command, docker build -t maintenance front end. This is the command that we'll be using, and dot. Let's go ahead and use this. So this will go ahead and build the Docker image around this. So if you see, it has used the Node 20 as a Alpine image. Now it is transferring the context. It is building this particular context. So it will take some time. Okay, that is done. So it has uh, copied the content that is required. It has installed the dependencies as well, and the Docker image is ready. Now if I go ahead and use Docker images, we should see two images, one for backend, one for frontend. So if you see, we have frontend image, which is created 12 seconds ago, and this is the backend image that I created earlier. And if you open your Docker desktop, here also you will see two images created. So if you see backend, frontend, so you can see maintenance backend and maintenance frontend. Now let's run the image. So Docker run -p on port 3000, and which can use the 3000 port on local and 3000 port on the application. And maintenance frontend, simple. I think there is spelling mistake, and this should sorry for this, maintenance frontend. So this should go ahead and open the or start the application. So you can see the application has started. Now I can go ahead and close everything, and let me again open the port 3000. And if you see, again the application is working on the Docker. So again, quickly test it by uploading the file. So this time let's check the engineering analytics only. Now the file is running on Docker. So if you see, both the Dockers are running, and if you see the logs, if you go to the open the containers, if you see, this is where the application is running on 3000 port, meaning our application is working well and good. Now it's time to deploy the applications. So for that, now let me go ahead and show you what and all details that are required. Now let me interrupt these terminals, both the terminals, because now the part is to deploy the application. So for that, let me take you to the whiteboard again. Now this particular part is done. We have created individual front-end microservice, we have created individual back-end microservice, and both the services are talking to each other on local host, and with the help of which we have built the complete application. Now the next step is, how do we make sure that we push this particular image to the the Elastic Container Registry. Now the thing is, I have not mentioned here how that imperative way works, but I will show you in the imperative way also how the things are going to work. So it's again going to be pretty easy. So if you see, first we will be creating the ECR service, which is a Elastic Container Registry, where we will host our images. Now these images that we created, right, currently these images are in local. how do we make sure that the deployed environment, which is somewhere hosted on cloud, be able to access that particular these images? So it will not be able to, because these images are in my local. So in order to store these images somewhere on the cloud, we need to create a ECR, right? And in that ECR, we need to upload these images. Okay, so let's go to our AWS console. So I'm opening the AWS console. Okay, so I have logged in, and here we can go ahead and search for ECR. So if you search for ECR, it will come Elastic Container Registry. So let's click on it, and let's go ahead and create. So if you see the option create, let's click on create. The repo namespace, let's give the namespace as, so we need to create two repository. One is for backend and one for frontend. So let's give the name as maintenance backend as the repository. Keep it mutable so that we can keep changing it. You don't need to set other details. So you can enable the scan on push. So enable scan to push to have each image automatically scanned after being pushed to a repository. Meaning whenever a new image is pushed to the image, pushed to these ECR, it will go ahead and scan it. So let's enable that and click on create. So if you see, it is pretty simple. We have created the repository maintenance backend, and this is the URI on which this particular image is hosted. Now, in order to push the image from local to this particular ECR that we have created, it is pretty simple. So if you uh, select this particular one, and if you click on view push commands, it will give you all the commands, and we are going to use these commands in order to push it. So just copy the first command. So what actually it does, so it can work on Windows as well as on Mac OS. So let's use this particular because our terminal is supporting Git and everything. So supporting Bash. So let's go ahead and use it. So if you see AWS ECR login, which will first get the login password and everything that we have set in the for our iTech user. So let's copy this one, which is basically in order to retrieve the authentication so that your Docker client can be registered into the CLI. So let's open the terminal, and in the terminal, let me clear the screen and let's paste this particular command. So if you see, ECR get login password -- region is TS1 docker login -- username and AWS -- password, and this is the image URI. So if I show you the image URI, so this is the image URI. So if you see repository URI, sorry, not image, repository URI. So this is the repository URI under which we are going to push the image. Sorry for my bad wording. Then let's go ahead and execute this. This will make sure that the terminal has access to the repository that we have built, and we are getting the error. So let's see, an error occurred, access denied exception when calling the get authorization, and this is happening because the ITIC user doesn't have access to pull or push the image, and for that we need to go to the IAM user again, and we need to grant the permission. So click on IAM user, and this is the user that we have created, ITIC user. Let's click on it, add permission. Let's click on add permission, attach policies directly, and here let's search for ECR, and let's see if we have full access for ECR. ECR full through cache. Okay, we can give EC2 full access. This is required. So EC2 is Elastic Cloud Container. So basically it provides you the cloud infrastructure that is required to host your Kubernetes and everything. So we have given this permission, it is required. So this Amazon EC2 full access is more than enough for us. So let's go ahead and add this particular access, and then we'll test it again. Add permission. Okay, the permission is added. Now let's go ahead and test it again. Let's go ahead and rerun the command. Now it should go ahead and okay, we are still getting it. So for the simplicity purpose, let's go ahead and add one more permission, which will fix all the issues. So again, it is not advisable. So let's add search for admin. And if you see, let's give full admin access. Let's click on administrator access, and let's next and add the permission. Now we have given administrator access for the ITIC user, so it should go ahead and work now. But yeah, if you search, you will get to know which is the exact permission that you need to give. But for the simplicity purpose, because we will be hitting lot many commands and I don't want to get into these errors again and again. So let's go ahead and hit this, and now it should directly go ahead and connect to the ECR that we have created. Okay, so if you see login succeed, now our Docker is having access to this particular ECR that we have created. Now let's go to the next. So again, go back to EC2 or ECR, and from ECR we need to view the push commands, and let's use this command. Now again, this command we have already ran it, but let's go ahead and run it. We are going to build the Docker image with name maintenance backend. And then meanwhile, let me copy the next command. This is basically in order to create the tag. And now why the tag is required, I'll show you. Let this particular Docker image create first. Okay, so the backend Docker is already created. So if you go ahead and do the Docker images, you will see the backend Docker image. So this particular image is created a minute ago. Now let's go ahead and use this particular command. Now this is very important command. So if you see, this command is basically in order to create the tag. So if you see Docker tag maintenance backend and latest, this is your local image that you are giving a tag as this particular URI 49, this DKR ECSTUS Amazon.com maintenance backend latest. Now this tag is required so that you can distinguish the image that is available in your backend and this particular tag image. So let me show you that. So as we have created it, and if I do Docker images, it will show one more tag. So if you see, these are the two old images that we have, backend and frontend, and this it has created new image with the tag. So this tag name is now important because with the help of this name, you can go ahead and push the image to the ECR. So if you see the last command, docker push, so docker push, and this is the command. So this is what we have created. So docker push image name. Now we already have the image name as this. This is the image name, right? So let's go ahead and hit. So this way it will go ahead and start pushing the repository to the ECR repository. So let's wait for this. Okay, so if you see, so it has started pushing these particular image to the ECR. So let's go ahead and check it out. On the ECR, currently if you see, there are no images, but the moment the image is pushed from the local, you will start seeing the image here. So let's wait for the image to get pushed. Okay, so if you see, we are about to push the complete image, and it is almost pushed. Okay, so the image is completely pushed. Now let's go ahead and check it on the user interface. So let's go ahead and refresh, and you should start seeing the image. So if you see, the image is available with the tag latest, and this is the URI on which the image is available. Then if you see all the information, this is the SHA ID of this particular image. From the SHA ID, you can detect which is the whether the latest image is pushed or not. So based on the SHA ID, you can detect it. So it's the latest push ID. Okay, so we already have created the backend repository, and the backend image is already pushed. Now let's create the repository for frontend, and let's give the name as maintenance frontend. And again, mutable, enable this, click on create. Let's open this and let's click on view push commands. Again, pretty simple. Let's go to the terminal where we have our frontend folder, and let's go ahead and start from this particular part. Again, this we have already done it. So, but now this is for the second repository. So let's see. It should be pretty quick because we have already given the access as an admin access for the iTech user. Okay, so this login is also succeed. Now the next part is, let's copy this. We are going to build the front-end image. Now this will go ahead and build the front-end image, and we have already defined everything. So the image is already created. And let's give the tag similar to the tag that we have created. Here we will create a tag. Now you should see 4 Docker images, one for two for backend, two for front end. So if you see, these are our normal front end and backend images, and this is the one for front end. For backend we have created with the tag, and now we have created this one with the latest tag. And this one we have created with the latest tag for our front end. And now we need to push it. So again, the push command is pretty simple: docker push and docker image. So this will start pushing the image to the front end repository that we have created. So let's wait for the push to happen. Okay, you can see it has started pushing the repository, and the front end repository is pretty lightweight as compared to the backend, because backend is the heart of the application. Front end, it just gives the looks and feel, right? So it's getting pushed now, almost done. Yeah, done. Let's go ahead and check it out. So let's close this and let's refresh. We should see the latest image available. So if you see the image available, this is the URI and we have the SHA ID. So everything is perfectly fine. Now we have achieved one step. So if I take you to the diagram again, so this part we have done manually instead of CI/CD pipeline, we have done it manually, and that's the imperative way of deploying the application that we are seeing quickly, right? And why it is required? Because this way it should give you the feeling that, okay, what and all things that you need to take care, or what and all steps that are available in the deployment. That's where we are doing the manual deployment. But in the organization, we don't follow the manual deployment. We create the CI/CD. But to create the CI/CD or create the deployment files, right, you need knowledge of these commands and everything, because eventually these commands itself go into the deployment file. So it is pretty important, and don't skip this particular part. Now this part is done. Next part is this. Now we need to create the EKS, that is the Elastic Kubernetes service that we need to create. Now let's go to the Amazon console again, and here let's search for EKS, Elastic Kubernetes Service. So let's click on it, and now we will be creating an Kubernetes service. So first of all, we need to create a cluster. Now why cluster? Because this is going to provide a compute power, cloud compute power, to run our application. So whatever load that is coming to our application, right, in local, the power was provided by our CPU. Here the power will be provided by the EKS, that is the EKS cluster. So for that we need to create the cluster. So let's click on create cluster. So we need to create a cluster, and under the cluster then we are going to define the compute power that is required for us to host our model. So let's click on custom configuration. We'll be doing a custom configuration. Let's disable this particular auto EKS auto mode. We don't need it. So it's basically to automate the routine cluster task and compute, right? So if there are any network and storage related upgrades, so basically it performs actions on those tasks. So we don't want to manage it automatically. So let's leave it. Let's give the cluster configuration name. Let's stick to the standard name that we have been giving. Aircraft maintenance. Let's use this. Cluster IAM role. Let's click on create new role. So I have already created a couple of I have already created the rules. Okay, so in this you can select a Amazon EKS auto cluster role. If this option is not available, you can click on create a role, and here you can add the configuration and you can create a new role. So I'm selecting this role, and if I click on edit role, so you can see these are the policies that are available under this particular role. So make sure you pass these particular policies. First one is the EKS block storage policy, which is in order to manage the storage related stuff. Then we have the Amazon EKS cluster policy to manage the cluster related configs. Then we have the compute policy, load balancing. Load balancing is basically in order to whenever the request is coming from the internet, this load balancer distribute your request with appropriate to the appropriate node and subnets. All that details is managed by the load balancing, and we are going to see that. So again, if I take you to the diagram, so if you see load balancer, application load balancer, whenever the request is coming from the user from the internet, through the internet gateway, it comes to the load balancer, and load balancer decides where you want to serve that particular user from. So currently we just have one node, but if there are multiple nodes, you can decide on which particular node we need to divert the traffic. So it does the traffic management stuff. And if this role is not available, you can click on create new role, and then you can define. I already have created the role, so I am selecting that. The Kubernetes version, let's select the latest version that is available. Standard policy, standard support, that's fine. Rest of the things you can ignore it. No need to touch to the other details. Let's click on next. Let's keep it simple. Then we have subnets. Now we have multiple subnets. Now what's the task of these subnets? So if you see this VPC I was talking about, so it is giving the feasibility, like with the help of the EKS service, it is going to provide us a VPC, that is virtual private cloud. So let me take you to the diagram again and I'll show you. So this is the VPC that it is giving. Under this VPC, we are going to build all our these infrastructure required in order to deploy the application with the help of Kubernetes service. And the subnet that we saw, so if you see the task of subnet is very simple. Under a VPC, you can create multiple subnets, and each subnet is basically to handle a request that are coming to that particular uh, nodes. So if you see under the subnet, we have these EKS nodes and pods. So nodes are basically in order to provide you the compute power, and pods where you can define a subsections under the node where you can deploy your microservices. Let's say in one pod you can deploy your backend, in another you can deploy your front end. And this is exactly what we are going to do. We are going to deploy two microservices under same node just to save the cost. But the subnet, what it does, let's say by some means, let's say if the resource that is available on the availability zone A is down due to some issues. So in that case, the user will be served through the availability zone B. And this is basically implemented in order to avoid the interruptions at the user end. So from whenever the user is coming from the internet, load balancer will detect if this particular server is down, user can redirect the user to this particular availability zone. Or if the uh, traffic to the availability zone 1 is pretty high, then load balancer can decide the new users that are coming in can go to the availability zone B. And again, I have given this example in my previous videos as well. So let's say the cricket match is going on and you are accessing this, or you are watching this match from the Jio Hotstar. And what happens whenever the initial couple of minutes, right? Let's say initial 1 hour in or initial half hour when the toss happens, right? At that time, let's say you are serving the users from availability zone 1 and the number of users are, let's say, 1 million. But the moment the match starts, that particular number grows to 3-4 millions, right? And in those cases, let's say one zone may not be sufficient to serve those users, and in that case you can switch to the another availability zone as well. But the main task of availability zone is to make sure that if anything goes wrong in the zone A, user will not be impacted and they will be served through the another availability zone. So that's how the subnets are there. And on the AKS, right, if you are adding the subnets, it is not charging you. So that's fine. We have added 5 subnets, and that is default data selected. So let's keep it as is. And in the cluster IP address family, we are selecting IPv4. Again, I'm not going into the depth of all these because I don't want to confuse you. Let's keep it very simple. How exactly you can go ahead and quickly deploy the application. The cluster endpoint, let's keep it public. Now, private and public, right? So if, let's say, you are building this particular application for your organization, then in those cases, and if the application should be accessible only by the internal organization people, then you select private. If the application is going to be consumed by the external people, those are not part of the internal organization, then you select public. For us to keep it simple, we are going to select public. So in private, you need to set up a VPN, the virtual private network, and all that stuff. So we are not going to select the private. Let's keep it public, and I am just trying to keep it simple. And then the control plane ingress is we are defining AWS manage. Let the AWS manage the ingress. So let's click on next. We're not adding any custom ingress. These things you can keep it as is. Let's click on next. And these are the selected add-ons. So default it has selected 5-6 add-ons. So that's fine. If you see, this is in order to track what and all things you want to track or monitor from the application perspective, right? You may need to monitor the node monitoring logs, what and all details that are happening with the node, whether the node is up and running, whether the pods are up and running. Those details you can monitor with the help of these. So again, I'm keeping it default. We don't need to change anything. Let's click on next, and that's it. So everything is fine. Let's click on next. No need to change anything there. And let's go ahead and click on create. Now this will go ahead and create the EKS for us. That is the Elastic Kubernetes service. And that is not the only thing that we need to create. We need to create one more thing, that is the node. So under this particular EKS, right? So we are going to create a node, and in the node we are going to actually define the configuration. What is the CPU compute that you need? What should be the memory of the application? What should be the storage? So all those details we need to define it onto the node. So if I take you to the diagram. So if you see, now we have built this particular part, Amazon EKS cluster. This part is ready. Now once this part is ready, then we are going to create a EKS node group. Under the node group, we also call it as worker group. In this, we are going to define, let's say I need a 4 core CPU, then I need let's say a 4 GB memory, 20 GB storage I need in order to host my, in order to keep my image and everything, right? So those details we are going to define in this particular node group. So let's wait for the EKS to get created. So let's refresh. It will take close to 5 to 10 minutes to create this particular EKS. So let's wait for that. Okay, so the EKS has been created. The next step is to create the node. So to create the node, you need to go to the compute section, and under compute sections, if you see node groups, so currently there are no node groups available. So let's go ahead and create the node. So click on add node group, and here we need to give the name of the node group. So I'm giving aircraft maintenance node. This is the name that I'm giving. IAM role, let's click on create new role. And let's wait. So if you see now, it is loading these mini policies. So if you see Amazon EC2 container registry read only, meaning this particular node group, it should be able to go ahead and extract or go ahead and read the image that is available on the ECR. So we already have pushed two images, one for backend and another for the frontend microservice. So it should be able to pull the images from ECR. Then EKS TNI policy, worker node policy, and register public read only. Those are a couple of other policies that are required, and if you see the description that is given here, you can go ahead with these particular descriptions. So but we need these four policies at the node level. So let's go ahead and create a role. So this role is already available, so let me give some another name, and let me create the role. Okay, so the role was already available because I was trying few things, so that's fair. Now next thing, you no need to worry about anything else. Let's click on next. And then next thing is the capacity is on demand and AMI type. So if you see, we are selecting Amazon Linux 2023 x86-64. So this is the system which we are going to use. On this system, it is going to execute the command that we are going to basically run. So this particular system that it is going to provide, right, whatever compute power that we are going to provide, it's going to use Linux as a machine at the backend, and Linux is the widely used system in the production environment or in the deployment environment. So the capacity type is on demand and the instances type, right? So if you see, there are multiple instances types are available, but the key thing here is, if you are on a free subscription, there are limitations. You may not be able to create the node with the free subscription, and you may need to upgrade the subscription. The reason why I'm saying, right, let me talk about it. So currently I've selected T3 medium, which is a 2 virtual CPUs, memory is 4 GB, and the maximum disk size, right, I'm selecting it as 20 GB. So 4 GB memory is required because our images that we have, right, each images, the backend image is close to 2 GB and the front end image is close to 5 GB. So uh, minimum 2 to 3 GB memory you would need in order to basically execute the application. And if you are selecting T3, obviously T3 is not accessible or is not allowed to select from the free subscription. So your node generation will fail. So if there are another option, you can go for the T3 dot nano. There is T3 dot nano. So if you see, but the memory is only 0.5 GB. So I'm not sure whether it's going to work, but yeah, you can give it a try. Nano is, I think, available, or you can go ahead with the micro. T3 micro is providing 1 GB, or you can go ahead with the small. Small, I'm not sure if it is available under the free subscription, but it provides 2 GB memory. So you can try these models. So you can try these configurations. So I'm going ahead with the 4 GB, but because I don't want any headaches at the once I create the node, so I'm skipping that. Disk size 20 GB is fine. Desired nodes. So I'm selecting one node because just to save the cost, we are not going to select multiple nodes. So minimum node is one, maximum is also one, and desired node is one. Because we are going to deploy the application using one single node only. So if I take you to the diagram. So if you see, we are using single node, and under the single node we are going to deploy the front end as well as backend microservice. Both are going to be under same EC2 instance, that is same worker node. But yeah, in real production application, right, you don't build in this fashion. You create multiple nodes so that if any node is over, if there is any problem with the node, you can switch to the another node, or if any one of the node is already occupying the complete memory, or if there is heavy load on the one node, then you can start serving the user from another node. So those are the purposes. But yeah, for this particular purpose, let's select one node, and then next you no need to select anything. You can just go ahead and click next. Subnets, this is fine. Again, whatever default subnets that are coming, let's click on next. And you no need to do anything here. Just go ahead and create. So this will create a worker node for us, a node group for us, and then we are going to access this particular worker node into our terminal, and from our terminal then we are going to hit some commands to deploy the application, because this is the imperative way of deploying the application, meaning the manual way of deploying both the services, the front end and backend microservices. We are going to write some commands in order to deploy the application, and we will test it whether it is working. Once this part is done, then we will go ahead and work on the deployment using deployment file, the deployment YAML file, and then we will automate that using the CI/CD workflow. So those are the things that we are going to see. Now, you may be asking, then why do we need this manual way of deploying? Because you should be understanding the commands that we need to execute. Again, I'm not saying that you need to mug up the command. If you use any AI model, it will give you the sample commands that you should be using. But you should be knowing which command to execute at what time. So those some details you should be aware about. So at least you should be aware about the overall process that we are following in the deployment process. So first you basically access, you create the node the way we are creating, then you create the pods, you create the deployment, and so you create the deployment and then you access those pods and then you serve that particular deployment, and there are further steps and which we are going to see. So let's wait for this particular node to get created. Again, it should not take more than 5 minutes, so let's wait for it. So, and you can keep checking the health. So here it should all show green, and let's wait for that. Okay, so it is still, so if you see, the cluster is actually active, and we just need to check now whether the compute is active or not. So if you go here, aircraft maintenance node, it is under creating state. Okay, so now if you see, the aircraft maintenance node group is already in active state, and let me refresh this to check. So let's go back to the cluster, and under the cluster, it should see, okay, so there are no any errors, so everything looks okay, everything is green, both the cluster as well as the node group is active. Now the next step is how we can access this particular Kubernetes service through our terminal. So let me go ahead and open the terminal. Okay, so first we are going to deploy the backend service, and then we will deploy the front end service. Now, so the backend image, we have already pushed it onto the ECR. So from there, we need to request the AKS to pull the image from that particular ECR and then deploy the application. So the first thing is we need to connect to the AKS service. And in order to connect to the AKS service, let's go ahead and use the simple command where we need to connect the kubectl to the Amazon EKS. So for that, I'm just adding a simple command. AWS EKS update kubeconfig -- region. This is the region that we are giving and the name of the cluster. So before executing this command, we need to make sure that we have defined the region. So let's go ahead and check whether the region is defined or not. And so to check that, just do AWS config. And under the AWS config, sorry, the command is AWS configure. Here you just need to add these details. I have already added it, but let me just, in order to check whether it is the group is defined, because initially I remember I did not given the I just used the default group, so default region group. So let's go ahead and pass these details. Okay, access key we have given, access ID we have given, access key we have given, and you know it, right? Like from where we have been extracting these details. So these details are already available under your IAM user. Default region name is this, so you can directly hit enter, or you can add the default region group, and then this is none. So now we already have it configured. So let's use this particular command, AWS EKS update kubeconfig. This is the region and name of the cluster. So let's grab the cluster name. So this is the cluster name that we have. Let's come back and let's add the cluster name here. Paste it as one line and let's enter. So this should return a success message. Okay, so if you see, added a new context, ARN AWS, this particular one, cluster, and this particular one. So it has basically updated the kube config file that is available in our this particular path. Now with this file we are able to connect to the AKS service that we have. So in order to quickly check that, you can use now kubectl. Now kubectl are the command that are given by the Kubernetes. We can use these commands in order to access the Kubernetes service. The way we use git commands, right? In order to pull the image, we use git pull. In order to push the image, we use in order to pull the code, we use git pull. In order to push the code, we use git push. So git is a command line manager, right? Similarly, kubectl is the command line manager for the Kubernetes. So we are using kubectl, and the simple thing is get nodes to check the nodes that we have created. So it should go ahead and show the nodes. Sorry, there was spelling mistake. Okay, so if you see, we are getting some error. The error is couldn't get the server API group. The server API group is missing, meaning some permission is missing. So let's go ahead and check that quickly. So if you see on the cluster, the iTech user that we have created, it should have permission to access this particular cluster. So if you go under the accesses, you will see these are the default permission that are there, but you see we don't have the permission for iTech user. We have the permission for root user, but the permission is missing for iTech users. So in order to add the permission for iTech user, let's click on create. And here just search for iTech, the user that we have, iTech user. So if you see ARN, this particular iTech user, we need to grant permission. And which permission that we need to grant? So if you click on next, add policy, and here we need to give the policy as Amazon EKS cluster admin policy. This policy we need to grant so that the iTech user can go ahead and access the cluster related information. So all the cluster nodes and everything it should be able to access. So let's click on next and let's click on create. So you should see one more permission added. So let's go ahead and again quickly check under the accesses. Okay, if you see now the iTech user has permission and we have given admin permission, so that we don't need to give the permissions again and again. So let's go back to the terminal and let's hit the same command kubectl get nodes, and now they should show the node that we have created. Okay, so if you see, this is the IP of this particular node and it is in ready state. So we are good to go ahead and use this particular node, and this node is 4 GB memory, 20 GB storage. That node, now we can go ahead and access it. Now the next thing is, once the node is available, now we can directly go ahead and create the deployment. Now in order to create the deployment, the commands are pretty simple. So let me again clear the screen. And the command is kubectl create deployment and the name of deployment. So the deployment name is maintenance backend is the deployment name that we can give. And after this, we need to give the image. So hyphen image, and we need to give the image name. Now from where we can get the image name? So again, if you go to the services and just search for ECR, the one that we created, and from Elastic Container Registry, we can get the URI for our backend service. So click on this. This is the URI for backend service. Let's click on it and let's paste it here. So if you see create kubectl create deployment, maintenance backend is the deployment name, and this is the image. So from this image, it is going to create the deployment. Pretty simple. So with this one command, it is going to create the deployment. So if you see deployment has been created, and in order to check the deployment, you can again use the command kubectl get deployments, and you will see the deployment. Sorry. Okay, so if you see maintenance backend is the deployment that is already ready to use, and it has created 17 seconds ago. Then you can also check the pod. So if you see kubectl get pods, on which pod we are going to deploy the application. So if you see, this is the pod that it has created, and it is currently in the running state. So the application, we have already created the deployment, and the pod is also ready to deploy the application. Now the next step is to start this particular deployment, meaning the image is there. How to start the app? To start the app, you need to serve the application first. So there is one command that we use in order to expose the application, right? So the command is kubectl expose deployment, kubectl expose deployment, and the deployment name maintenance backend is the deployment name that we have given. And after this, we need to give the type as well, and the type is pretty simple. We need to give the type as load balancer because we are using load balancer in order to divert the traffic. The backend runs on port 80 and the target port is 8000. So this is what we have given. So the final application is going to be work on the port 8000. So let's go ahead and hit enter. So this will expose the deployment, and once the deployment is exposed, okay, maintenance backend is not found because I made some mistake. So let's use this and it should work now. Okay, so if you see the service is already exposed, and in order to check the exposed service, you need to use the command kubectl get svc, that is the services that are exposed. And you should see here now, if you see, the application is working on, so maintenance backend is working on port 80. This is the port, and load balancer is this, and this is the external IP address. So if you copy this particular address, you should be able to access the application. So this is the external IP address. Let's copy this address till .com, and let's go to the browser and hit. Okay. So it is saying not secure, and it is not able to load the site. Let's go ahead and check what's the issue. So the problem is, okay, there is no response. Okay, I got the issue. So the thing is, in the deployment environment, so if you remember when we tested the Docker file, we created this .env file to pass the secrets. So we need to create a secret on the Kubernetes so that it can read these secrets from that particular Kubernetes secret. So in order to create the secret, I'm going to add one command. So this is the command that we will be using: kubectl create secret generic AWS credential, and these credentials we need to pass now. So first thing we need to pass is AWS access key ID, which I have already copied it. So I'm going to copy that particular ID, and you can get this particular ID from the iTech user that we have created. So let's go back and let's add these details. First is the access key that we need to define. So we have defined the access ID. Then from literal, we need to define the secret as well. Let's go ahead and define the secret. So I'm adding the secret value now. Okay, those two things that we have added, and our AWS region is already US East 1. So let's go ahead and hit enter. This will create a secret. Now, the secret, if you see, it has already created the credentials. So let's go ahead and check that. So again, kubectl get secrets. If you do, it will show you the secrets. Sorry, again, spelling mistake. Sorry for that. So if you see, AWS credential is the secret that we have created, and this is the name that we have given, AWS credential. So from this, now we need to request the model to read the secret from this particular point. And in order to do that, we need to inject the secrets. So the simple command that we have in order to inject the secret is this: kubectl set environment under the deployment maintenance backend, and from this particular secret we need to define. So once you execute this command, it is going to set the secrets into the environment variable, deployed environment variable. Now this is done. Now in order to access the application, we need to restart the application or restart the deployment, and the command is pretty simple: kubectl rollout deployment name. Oops, sorry, I missed one part. Kubectl rollout restart deployment. Sorry, my bad. Okay, so this will go ahead and restart the deployment. So if you see application has been restarted, now you can go ahead and again, if you want, you can go ahead and check kubectl get svc in order to check where the application is running. So it is still running on the same part. And if you see now, if I'm refreshing it, the application is running on this particular endpoint. And in order to check whether it is working or not, you can go to the docs, so that it will open a Swagger page, and from there you can test the application. So okay, so congratulations, we have deployed our the first microservice, that is backend, and this is the heart of our application. So backend service is already deployed. So this is the endpoint on which the service is available. Now you can go ahead and access this particular application on incognito as well. So it's not running in local anymore. So if you see from any, if I share this link with you, you guys can also go ahead and access this. But in order to make sure that it is not charging me a lot, unfortunately, I'll have to delete all the resources before sharing this particular video. Sorry for that, but that's the reality. Now the thing is, let's go ahead and check it. So first of all, test health and everything, that is fine. Let's go ahead and check whether the application is working. So let's choose the file, let's add this data, and let's execute it. So it should go ahead and generate the response. So if you see the application is working, it is generating the engineering metadata successfully. And let's check whether our second service is also working or not. If not, we may need to grant several permissions. So most probably it should work. So I'm copying this output, try it out, and let's give the data and let's execute it. So it's loading. Now, as we have given admin policy rights, right, for the ITech user, so this should, because this is using the ITech users credentials at backend, but ideally what happens, right, in the real organization, you create a user groups and you grant permission to those user groups. And for these applications, you create a service principals, and you basically, instead of the individual user, you request, you grant permission to the service principal, and your service principal can talk to these services internally on behalf of any individual user. So that's the standard way of implementing the project. Okay, fantastic. The AI call is also successful and everything is working. So if you see, it has generated the recommendation as well. So bingo. So our backend application is fully working end to end. Thanks for your patience if you are watching this particular video till now. So thanks for watching this particular video, and it takes a lot of effort in order to watch this long series, but yeah, this is really worth it because we have deployed our first AI application using our AWS ecosystem. Now the time comes to, now the time has arrived where we need to go ahead and deploy the front end as well. So let's switch to the front end command terminal, and let's go ahead and start doing the same things for the front end as well. Now the first permission is already given, the secrets are already set. We are going to use the same node in order to deploy the application. So first of all, let me show you. So if I'm doing kubectl get nodes, we just have one node, and in the same node, if you see, on the same node we are going to deploy our second application. And if I do kubectl get pods, so you will see only one pod will be there. So if you see, this is the backend pod on which the application is running. So the status, if you see, it is running. Now let's go ahead and create the deployment for front end. So again, kubectl create deployment, and the name is maintenance front end. Let's give this particular name. Let's hit enter. Image is not set. Oh, I'm really sorry. You need to pass the image equals to, and let's go back to the application, and from here we need to select the front end image. This time let's select this image, let's pass the image, and let's create it. It should be pretty quick. So if you see, the deployment has been created, let's use kubectl get deployments, and you should see both the deployment now. So if you see, the deployment backend and front end both are there. This was created 11 minutes before, and this was created just now. And if you see kubectl get pods, now you should see two pods, because the backend is microservices running on this particular pod, and the front-end service is running on this particular pod. And if you want to check the logs of, let's say, backend, so kubectl logs, and you can pass the pod name. So this is the pod on which the backend is running. From here you can go ahead and basically read the logs as well. Okay, so if you see, this is the backend logs. So all the logs that we have defined, right? This was the reason I was asking you to add the logger whenever you are writing the code. So with this, you can see everything, which endpoint it is calling, and everything is mentioned in these particular logs. Okay, now let's go ahead and basically expose this particular service as well, front end. So kubectl expose deployment maintenance front end. We need to define the port as well. So let me quickly grab the port. I think we are running it on 3000 port. So let's add the type as load balancer port 80 to 3000. Let's go ahead and execute this. Now this should create the deployment. So if you see, expose the deployment. So the port has been exposed, and in order to check that, the deployment has been exposed. So kubectl get svc, which will take us to the service where exactly it is running. So if you see, the backend is running on this, front end is running on this particular URL. So let's copy it and let's go ahead and check whether we can access the front end or not. So let's go ahead and hit this. It is not running. So let me close this particular tab. It is not running. Let's go ahead and check what is the issue. So again, in order to check the issue, first of all, let's use kubectl get pods. This will get us to the pod, and from that pod we can see the errors. So from the pod we can print the logs. So kubectl logs, and you can get this particular, copy this particular front end, and you can add -f as well to get the full logs. And let's see what are the logs, why it is failing. Okay, re-optimizing dependencies, white package has changed. Oh, okay. So if you see the issue in local, it is still referring to the old backend actually. So that is the issue. So if I'm refreshing here, right, it will not work because in the behind the scene in the backend, it is not calling the right backend. So it is still looking for the backend which is running on localhost, and this is because, so if you open this particular package, if you open this env file, here we have defined the white API base URL as this particular one. So we need to change this, and in order to do that, first of all, we need to go to the client.js, and here we can go ahead and replace this particular part. So first of all, in order to make it work, so let's set this particular path in the env itself. Here you can replace this with the one actual backend one. And one more thing that we need to do is, okay, sorry, I forgot to add the HTTPS. You need to add the HTTPS as well. And one more thing that we need to add is under the white packages. So here, if you go ahead and add this particular part, allowed host true, meaning it is going to allow all the hosts. So what exactly this is going to serve? So what the purpose this particular one line is going to do? So this is going to allow all the requests that are coming from the external host, because now the application is deployed and the public user is going to access this particular application. So it should accept those particular requests. So you need to make this one change, and then this part. Now again, as we have done this, you need to rebuild the image. So let's terminate this, and you need to rebuild the image. So because the reason you need to rebuild, because the image that we have posted on the ECR, it is the older image. So you need to rebuild the image, you need to push it to the ECR, and then you need to go ahead and redeploy the application. So let's go ahead and quickly do that. So, and again, purposefully we have kept the errors as is, so that you will also get the real-time feel how we fix the errors. So let's go ahead and run the command, or you can go to this particular one, ECR, and we already have the commands available here, right? View push command. So let's go ahead and run these particular commands first. I think this part is already there because we already have access and we have logged in to the ECR. So let's go ahead and execute this. This should return success. Okay, this is success. So we are able to log in. The Docker is connected to the ECR. The next command is to build the Docker. So let's go ahead and build it quickly. So I have saved the files, and let's check. This should be pretty quick. Okay, this is done. Next part is to create the tag. We already followed these methods, so I'm simply doing it pretty quickly. And then push the image. So with this command, now we are pushing. So this is going to push the image to the ECR, and once the image is pushed to the ECR, we can go ahead and rebuild the deployment, or we can go ahead and roll out the deployment again. So let's wait for this. And again, if you see, we have added the environment into the env file. You can again set this particular environment into the secrets, the Kubernetes secret as well. Okay, so this part is done. Now let's go ahead and check whether the image has been pushed or not. So here, let's refresh it. And if you see, this particular request is pushed just now. Okay, so it means it's working fine. And let's go to the terminal and let's go ahead and roll out the deployment again. So the command is pretty simple. Kubectl rollout restart deployment, and the deployment name is maintenance frontend. This will go ahead and restart the deployment. Okay, the deployment has been restarted. Let's check kubectl get pods. Okay, both the pods are running. Now kubectl get svc to check where exactly it is running. It is running on the same port, same endpoint. Let's go ahead and check it out. Bingo, the application is working. So if you see now, it is able to access the backend as well. Backend is online and the application is working on this particular endpoint. Whew. We have put in a lot of efforts to make it work. So finally the deployment is there. Now let's go ahead and check whether it is working or not. So let's click on choose file. Let's upload the data. Let's click on generate analytics. Cool. It is generating the analytics. We have these particular informations, the sensor information and all those, the signal trends and everything. It is increasing, decreasing, all those details. Let's pass the manual as well. And let's click on generate AI recommendation. So now this will go ahead and hit the call to the Amazon Bedrock, and from there it will go ahead and generate the response. So finally, we have the working application ready. End-to-end application we have deployed using AWS ecosystem. Now, if you see here, it is not secure because it is using an HTTP protocol in order to access the request. There are a couple of things that you need to work with your security team in order to make it change it to HTTPS, which is a secure protocol. And there are a couple of things that you need to work on in order to make it happen. Like currently, if you see the address is pretty bad, like user will not be able to understand what exactly it is. So in order to make it simple, you will have to do the domain configuration. You can go to the GoDaddy and you will have to, let's say, purchase a domain name or any whatever your industry is using, right? Whatever your organization is using, you can go ahead and you can purchase a domain name, let's say aerocaremaintenance.com. And once you configure it, then once you hit aerocaremaintenance.com, it will basically reroute the application to this particular port again, this particular URL, and then the application will be working. So that's how it happens. So if you see, we have the results ready. So ground the aircraft. This is what we have seen in the local as well. So at the time it was running on local, and these are the reasons why to ground the aircraft, and everything is already listed. The inspection checklist is there and the work order is also created. Fantastic. Everything is working just like a makkan. So hope I was able to cover all the sections and all the details thoroughly. So just to help you out, I have created one imperative document. So let me add that imperative document here itself. So I will push this document as part of this particular code. So you will get that in the GitHub itself. So this is the document that I have created. You can follow these steps. You need to create a Amazon EKS clusters and everything, and then I have added the commands as well. You can use these commands in order to go ahead and execute. You can go ahead and use these commands in order to basically create the deployment and everything. So just a standard manual that I have created. You can please feel free to go ahead and refer this document if you have any issues. And still, if you are stuck anywhere, just reach out to me. Just drop your comments into the comment section. Okay, now the next step is create a deployment. So the deployment that we have done now, right, it was using a imperative way, like we have used the manual, we have hit the manual commands in order to deploy the application, but that is not the standard that the industry follows. Instead, what industry does, industry creates all these commands in sequence into a one file. They call it as deployment.yaml file, and then they just run that particular file to make sure everything is automatically executed or everything is automatically taken care of. So in order to make that, we need to create a deployment. So let's go ahead and do that. So for that, here if you see, we have backend and frontend as two folders created. Let's go ahead and create one more folder called Kubernetes, where we will add all the Kubernetes related deployment files. So first of all, let me go ahead and add the backend file. So in order to save the time, I'm just going to add these files. So under the deployment, let me paste one file. This is backend deployment.yaml. Now, as we have two microservices, we need to create two deployment file, one for the backend microservice and another for the front-end microservice. So this one is for backend deployment. So if you see, a deployment ensures the desired number of backend pods are always running and all those details that we have added. Now, if you are new to the deployment files, how we write the deployment files, what are the each details that we are mentioning in this, right? So you can follow my previous video as well. You will get the link in the description below, where I've covered how to write these deployments files in depth. Though it was we use the Azure as ecosystem to deploy the application, but writing these deployment files and everything is similar only. So let's go ahead and quickly check. The kind is deployment, which determines the kind of application, what kind of operation that you want to perform. So first one is deployment, because this is the deployment file. There are other as well. Kind can be secret, where you are defining your secret. Kind can be service, where you are exposing any service. So it's that simple. Metadata, this is the app name that we have given. Replicas, we just need one replica. That's what we have been defining. Then this is the app. That's fine. Again, these templates and everything, I have kept this particular file bare minimum. These are the sections that you need to define. And again, I have kept the file very, very simple. So if you see container, this is the container name. Image, we are going to pass the backend image. How we are going to pass this image, I will talk about it. We need to set these secrets on the GitHub. We will be setting those secrets as well. Then the image policy, it is always. Then ports, 8000 is the port on which this particular application is going to run. And then we need to pass this secret as well. So if you remember, we created AWS credential as a secret. So you need to pass these value as well. But the thing is, here we have defined these backends and everything, right? So it is going to create this particular backend deployment. But this particular service, so every time you cannot go and manually create this service, right? Before whenever you are basically deploying an application, so you need to keep it automative way. So for this particular secrets to we need to add one more file to create this secret, and that file I'm adding it now is the aws secret.yaml. Okay, so if you see, kind is secret now. Earlier the kind was deployment, now the kind is secret. The name of this particular secret is AWS credential, type is opaque, and we are passing these secrets. So region we have hard coded, access ID and the access key, right? We need to pass these details. So here we need to pass, here it is just mentioning that your AWS access key and your secret access key. Again, we are not supposed to add the secrets here in the file. So let me just change it, and we will be reading it from the GitHub secret. So instead, let's use this particular one to read this particular secret. So you can go ahead and change this. And instead of this, you can add this part, your AWS access key ID, and then, sorry, instead of you, let's remove the yours, it's not required. And let's remove this as well. So we have added these two secrets, AWS secret key ID and AWS secret access key. So those two things that we have defined. Now this is going to create the service first, then that service will be secrets, and that secrets will be available under this particular backend. Now let's go ahead and create the front-end deployment file as well. So let me add the front-end file. So this is the front-end file. If you see front-end deployment, again the kind is deployment. The application name is maintenance front-end. These details we have already seen, and here we are defining the image. So this is the image, and again we need to set this image on the GitHub secret. I'll show you how to set that. So this is accepting the parameter. So we are parameterizing those things, and then it is going to run on 3000 port. Again, very simple. Here we are not adding any secret, so let's leave it. The next thing that we need is the service file. Once this particular deployment is created, you need to serve the deployment. So remember the command that we used, expose command, kubectl expose, and the deployment name, that is maintenance backend, maintenance frontend, and the port. So we need to define that particular service as well. So you need to create those files as well. I'm keeping it pretty simple. I'm keeping it segregated so that you know, but ideally you can add everything as part of one YAML file itself. Like all those details you can add one below the another. So if you see kind, it is service now. So first kind will be your deployment, then kind will be your secret, then kind will be your service. So you can add everything in one file itself. But just to follow the industry practices, I'm keeping creating separate files so that it is easy for you to understand. And these files are pretty small, right? Just 10-15 line of code. Again, kind is service. This is for backend. Type is load balancer, and this is the protocol HTTP. TCP is the protocol that we have given, and the port 80 and the target port 8000. Same thing. So if you remember the command that we used for the application, this is the command that we use, right? kubectl expose deployment maintenance front-end type load balancer and port. Same thing where we have defined here. That's the reason we have seen the manual or imperative way of deployment, right? Now it is pretty helpful for you to understand what these particular YAML files are. And the last one is we need to add the YAML file for front end as well. So let's go ahead and paste it. And this is the front end file. Again, the name, type is load balancer, and the target port is 3000. So we have added it. Now, how do we make sure that we run this particular files? So in order to run it, first of all, what you need to do is you need to create a workflow, and that workflow you can go ahead and manually trigger it. So what I'm going to do is under this, if you are aware of any previous deployments, we create .github workflow as a folder, and under this again I'm going to create a folder called workflow. Sorry, it should be workflows. And under this I'm going to create a file deploy.yaml. And this folder should be at home directory. Sorry, by mistake it was added there. Okay, so now under the deployment.yaml or deploy.yaml file, we are going to write our code. Sorry, it should be YAML. And under this file, let's write the line of code in order to make sure that it is going to execute these files. So we are just going to call these files one after the another and going to perform this deployment. So let me add that particular file here quickly. This is pretty simple file again. So okay, so if you see, the name is deploy AI aircraft maintenance platform. First of all, whenever the push happens to the main branch, it is going to trigger the workflow. So for now, I'm going to keep it to some another branch. Let's say, let's give the name as test branch so that it should not trigger the workflow the moment we push the code. Runs on Ubuntu latest. What this means, in order to execute these commands, you need a compute power, and that execution is going to be happen on Ubuntu latest. So it is going to create a virtual this particular Ubuntu latest machine, and on which it is going to run this particular command, and that is going to be managed by the GitHub. That's the reason it's the GitHub CI/CD that we are GitHub Actions, right? It's for that purpose only. So if you see, we are reading the secrets from the GitHub secrets. So these secrets we need to add it. That's fine. We will be adding it. Then we are defining the checkout repository and everything. It's just to check out the repository. So it keeps checking whenever the code changes happen to that particular repository, it will go ahead and start the workflow. Then configuring the AWS credential first. So these are the credentials that we need to set. Sorry, it is reading these secrets. So from secrets that we have created, right? Secret is AWS config secret that we have created. It is going to access these particular two keys, and from env it is going to read the AWS region. Then we have the login to the ECR. Now the first step that we saw whenever we were doing the imperative way, right? We had to log into the ECR and then we had to push the images. So this particular part is going to log into the ECR. This part is going to build the Docker image. So if you see Docker build -t maintenance backend, same thing that we have been adding here. Then the tag backend image. So we are going to tag that particular backend image, and this is again we are going to read it from the GitHub secret. So we need to set these parameter, and then we are going to push it to the ECR. Once the push is done, then next part is to push the front end. Now, as I mentioned, right, in this deployment file, I'm adding both backend and front end together so that we can push, or as soon as the workflow is triggered, it will go ahead and deploy both the services. So then this again, it is not a standard way of doing it. Sorry, in order to save the time, I'm doing in this fashion. If you have, if you are working on real industry, you create two separate deploy file, for one for front end and one for backend. So whenever the change happens to the backend repository, it will go ahead and trigger the backend workflow. Whenever the change happens to the front end repository, it will go ahead and trigger the front end workflow only. Then you are building the image for front end, and again you are tagging it. We are getting it from the front end. We need to set this parameter onto the GitHub secret. Then you are pushing it, and then the configuring the kubeflow. So the environment on which we are executing this command, right, you need to configure. So if you remember, the first command that we ran is AWS EKS update config, where we pass the AWS region name and the EKS cluster name. So those it is going to read it from the GitHub secret. We need to add it, and then it will go ahead and run. Basically configure the kubectl in the environment where we are running these particular commands. And then this command is in order to replace the backend image. So these particular deployment files, right, it doesn't understand, or this file doesn't understand what exactly is this dollar and backend image. So in order to make sure that you are replacing this backend image with the actual deployment, actual backend image, that's where you need to use this command std and this particular part. Same for the front end as well. So that whenever, so if you see from the backend deployment.yaml, the backend deployment.yaml that we have created, and this particular file, it is going to replace the front end image that is available under this particular file with the actual image value. So if I open the particular file again, backend deployment, so if you see you have backend image, so it is not going to understand what exactly the backend image. So that is what we are passing it through this particular ACD. Then creating the Kubernetes secret. This way we are creating the secret. So if you remember, we created the secret, and these are the secrets that we need to pass it. Then we can define these secrets. Now, I think I made one mistake. It is not calling these secret files in order to create the secret. Ideally, I would have directly given this particular file itself, kubectl apply and this particular AWS secret.yaml. So there is one flaw, sorry for that. But yeah, you can just change it. The way we are going to do it for these backend and front-end deployment, it is in the same fashion. So deploy Kubernetes resources, deploy to Amazon EKS, kubectl apply -f and Kubernetes. So with this, whatever is available under Kubernetes, right, we are going to deploy it. With this command, it is going to run these particular files together and verify the deployment. So with simply this one, right, even you no need to define these, because it is going to create, this particular part is going to create the secret. So this is not required actually. With this apply command, it is going to run all the files that are available under Kubernetes. So first it will run this file, these everything, and then once you run these files, it has the expose commands as well, right? It has the service command, service YAML files as well. So it is going to make sure that it is going to not only create the deployment, but also it will go ahead and expose the deployment. It will run the service as well, and then it is just the verification. It will wait for the backend. So with the help of this particular, it is going to check whether the two backend and front end services are up and running, and then it is going to just run these commands in order to check whether deployment is success or not. Pretty simple file. So we have added all the details, and these files it is just calling. And before this, right, we have just done the configuration to make sure that we are pushing the images and everything, because image push is not part of this. So if you see, we have not added anything to push the image, so that anyway we had to define it in this particular file. Once the image push is done, we are directly calling these particular files in order to deploy it. So with this one line, it has reduced our work, or else this file would have grown to next 100 more lines, right? So that we have saved it with this, writing these particular individual files. Okay, so we are all set. First of all, let me push this particular code. So let me open the GitHub, publish to GitHub. Let me click on it, and let me click on publish to the public repository. I'm adding GitHub backend, this file, frontend and Kubernetes, all the files. Yes, let's select OK, and it is going to push the detail to my GitHub. Okay, successfully pushed the file. So let me take you to my repository. This is my repository, and you will get the link in the description below. So I have already uploaded all the code. So this is the code that is available. Now, this pending deploy is going to fail. That's fine. Now, if you see, the code is already available. Now we need to see how we can go ahead and run the particular workflow that we have defined. So first of all, first thing that we need to do is we need to go into the settings and we need to add the secrets. So under the secrets and variable, click on actions, and we need to add the secrets here. Let's add create new secret, and as per the file we need to create the secret. So first one is the backend image. Let's go ahead and create it. Name is backend image, and you can get the backend image name from this. You can go to ECR. This is the backend image. Let's add it. Add secret. New repository secret we need to add is the front end image, and the name is I think I should open the deploy.yaml and we'll get everything. Front end image. Let's add the secret. Next one, let's create new repository secret. AWS region. Let's add the region as, so I'm adding the region. Next secret is AWS account ID. Let's go ahead and add the AWS account ID. Again, if you want, you can feel free to skip this particular step. So I'm adding the account ID. Then we need, sorry, I think I used the wrong one. We need account ID. So account ID, you can get it from here. So this is the account ID. So let me go ahead and update the secret. Let's edit it. This is the value, update secret. Next is EKS cluster name. Let's go ahead and add the secret. And cluster name, you can get it again from here, EKS. Maintenance cluster is the cluster name. Then, okay, these secrets we have added. AWS key. And I already have the key with me, so I'm adding the value. Next one is secret key. And let's check if we miss anything else. Backend image is there, everything is there. Front end image, case cluster name, AWS region. Okay, I think we have defined everything. Cool. So we have added all the secrets now. Now we are good to trigger the workflow. So before that, right, let me go ahead and delete the deployments that we have. So from here, right, so if you see, we have a couple of deployments. Let's delete these deployments so that we can test the CI/CD part. kubectl delete deployment and deployment name. Then kubectl delete deployment and deployment name. Front end. Now let's check kubectl get deployments and it should show nothing. Okay, no namespace found. So we have deleted the deployment. Also, let's delete the service. kubectl delete svc. Sorry, secret. kubectl delete secret. Oh, sorry, we need to check the secret name first. kubectl get secrets. Delete secret and the secret name. Let's see if it deletes it. Okay, it's deleted. Now we have removed the secrets and everything. Now let's go ahead and check whether this is going to trigger the workflow or not. So you can go to the actions on GitHub Action. So this is what we are going to use, GitHub Action. And let's click on this deploy and we will go ahead and manually deploy it. And click on this view workflow file. This is the workflow file that we have. And let's see, run all jobs and deploy. Let's see if it fails, we will fix the issues. First commit was failed. Let's see what is the issue. So if this also fails, we'll go ahead and check it out. Currently it is in queued state. Okay, so if you see, the deployment has started. So if you remember, we added test as a repository. So whenever the push happens to the test branch, then only the workflow will be triggered, and that's where the failure was. But now if you see, it is doing all the tasks. So first of all, it has done the image building, front-end image building and everything. So I'll show you that quickly. AWS configuration is done, login to the ECR is done, tagging of the image, backend image, pushing to the backend image push is done, building the front end image. This part is done, tag front end image, pushing to the front end image. kubectl configuration is done, then update backend manifest, front end manifest, create AWS credential secret, that is also done, deploy to EKS, that is also done. Wait for the front end, it is checking. Oh, done. The deployment is successful. In one go, I was able to complete the deployment. It hardly it happens that in one go your deployment gets successfully deployed. So, but yeah, maybe we are lucky. So the file was successfully deployed. Now the thing is, we need to check whether it is already actually deployed or not. So here you can check kubectl get deployments, and it should show the two deployments. Okay, if you see backend deployment, front end deployment, and here if you see kubectl get svc, it should show the two application that should be running, because we are exposing as well. So if you see, it is already running. So let me copy and show you that. Some issues, we'll fix it, no worries. Let's check what's the problem. So first of all, let's check whether the secret is created or not. kubectl get secret. Okay, secret is also there. Then let's check what's the problem. So kubectl get pods, and I think the problem is with. Let's check whether backend is running first. So kubectl get svc, and we'll check the backend application first. So this is the backend application running. Let's go ahead and check if it's running. Okay, backend is also not running. So let's quickly check what's the issue. kubectl get pods, and then kubectl logs -f, and let's check what's the problem with backend. (404) not found. 405 method not allowed. Invalid HTTP request received. Oh, this is a HTTP. We'll have to change the protocol to HTTP and it should work. Okay, cool. Bingo. The deployment is successful. Failed to connect. Okay, so the backend is still failing, and this was expected. So if you can recollect, we have added a git ignore file, and in which we have added .env. So it is ignoring the .env file, and in the back front end, right, we need to set the white URL. So that part is failing. So if you see, it is still hitting to the localhost. So we need to fix that. So what you can do is you can pass this particular backend URL into directly in this particular part. The client.js here, instead of the env, you can directly set it here. Okay, so what I have done, I have added the API base URL directly here, and I have changed this particular file. And one more change that I have done, under the deploy.yaml file, I have changed it to main. So the moment we push any changes to the main, it will go ahead and trigger the workflow. So let's go ahead and push it. So new backend URL, let's add it, let's commit it and sync the changes. Now let's quickly go to the repository and let's monitor the repository here. So it should trigger the workflow. Okay, this is there, and let's refresh it. Okay, you can see the workflow is triggered. So automated CI/CD is working on now. Let's click on details. So now whenever you're pushing any changes to the main repository, it is triggering the CI/CD pipeline automatically. So if you see, the image building and everything is going on. So now it is pushing the backend image. Once the backend image is pushed, then it will go ahead and build the front end image. So if you see building the front end image now, Then it will go ahead and tag the front end image, push the front end image. So if you see it is pushing the front end image, then it will configure the kubectl backend manifest, front end manifest, everything it is doing it, and AWS credential secret deploy to AWS EKS. Everything is done. List resources, post checkout repository. Okay, done. So the deployment is again successful. Now let's go ahead and quickly check if the application is up and running. So here let's go ahead and refresh it, and it should show now the backend up and running. Oh, the backend is still pointing to the 8,000. Okay, but why so? Looks like we will have to restart the deployment. So let's go to the terminal and roll out, restart deployment, maintenance front end. Let's see. So once the deployment, okay, the deployment has been restarted. Now let's go ahead and refresh it. Now it should work. Okay, so backend is online finally. Let's quickly go ahead and test the application, whether it's working. Let's generate the analysis. Okay, it is generating the analysis, and let's see whether it is generating the AI recommendation as well. Failed to connect to this particular one, prediction maintenance prediction API failed, unable to invoke Bedrock model. Okay, there is some issue in the Bedrock model. Let's go ahead and fix it. Okay, so the issue is in this particular file. So if you see the parentheses are missing. So what we can do is let's remove this particular file. We don't need it. So I'm deleting this file, and under deploy.yaml. So if you see, we have a code to create the secret and overwrite if it is available. So if you see create and update the Kubernetes secret. So from here it will go ahead and create that. So let's save this, and let's go ahead and add the file, fix secret bug. It missing the changes. Let's go ahead and check whether the workflow is triggered or not. So here the workflow is triggered. So let's wait for the workflow to get complete. Okay, so as the workflow is completed, let's go ahead and check it out. So let's go ahead and restart the deployment first. kubectl rollout, restart deployment, maintenance backend. So let's roll it out, and okay, the deployment has restarted. Let's go ahead and check it now. So select the file, generate the engineering analysis. So it may take some time because we have restarted the application. Okay, now let's go ahead and click on generate AI recommendation. Now this time it should go ahead and hit a call to the Amazon Bedrock, and it should load the model. So let's wait for it. Cool. Okay, so if you see, it has generated the result that the AI maintenance recommendation ground the aircraft, so it's working. So the whole end-to-end application is working, and we have used GitHub Action in order to automate the CI/CD as well. So I hope this particular series was helpful for you. I hope you understood this project thoroughly. So, and I hope you will be able to build the end-to-end AI project now, and also you'll be able to deploy the application using the AWS ecosystem. So now once you are done with this, I know like we faced multiple challenges, but this gives a little bit, this gives a different kick to fix the issues on runtime. So we fixed all the issues, whatever issues that we came across, and these are the genuine issues that you will also encounter whenever you are working on these projects, or whenever you are working on your industry projects. So we keep facing these issues, and it's uh, pretty important to fix these issues and understand what these issues are and why these issues are coming in. So yeah, I know it took little longer to fix some of the issues and all, but I hope at the end it was a good learning for you as well, because uh, ideally we learn from the mistakes itself. So for me it was a pretty good learning to fix some of the issues, because some of the issues were new to me as well. I hope this was helpful for you as well. And once you are done with everything, I would highly recommend go ahead and delete all the resources that you have created. So the EC2 instances, the EKS service that we have created, ECR service we created, the user that you have created, right? So delete all these details, delete all the resources so that it will save your cost. And keep monitoring the resources. By mistake, there are chances that some of the services may remain active, so you will have to come and delete those services if there are any, in order to avoid the unnecessary extra cost. So with this, let's conclude this particular project. And if you are interested in more such projects, if you want me to cover any different topics, please let me know in the comment section. While implementing this project, if you come across any issues, let me know in the comment sections, and I would be happy to answer those questions. So yeah, let's end it now. Thank you so much for watching this particular video. See you soon in the next interesting series. Thank you so much.